Hello, welcome everyone who's watching to this, the first that we've ever done of Dyalog live stream Adventures in Advent of Code. So today it's myself, Rich Park, joined by an excellent collection of panelists here that we'll get around to introducing in a minute, and maybe one person might join us later. But first, yeah, thanks everyone who's watching. Can see people are pretty active in the chat already. So the plan for today is fairly loose. We have a collection of people here who've all participated in some way or another in the Advent of Code challenge. I expect that most of the people watching do know what Advent of Code is, but if you don't, it's an annual programming challenge where throughout the lead up to Christmas, from the 1st of December, there is a programming challenge every single day. And part of its really wide appeal is that it doesn't matter what programming language you choose to solve the problems in. You get some puzzle input, some text, and you have to pass that, solve the problem, and produce. Is it always? It's typically some number as the output that you paste into the website.
Sometimes
and
words,
what
I think.
sometimes
Rarely,
words.
yeah.
It's always some ASCII text that you paste in. It's usually digits. Another thing that's been quite a boon, I suppose, is people discovering APL through the Advent of Code. It's quite a popular challenge for people who are learning APL and array programming in general. Especially the early problems are very accessible for people who are new to programming, new to APL. Some of the later problems maybe get a bit computer sciencey, but I don't know. We'll see the opinion of people around. But yeah, so that means that we have people who are discovering APL, people who are trying to solve the problems in APL, and that's really nice for us to see. So what I have is basically a list of problems, the problem numbers that people in this panel have said they've have worked on a bit or solved in some capacity. And we're basically going to go through that list in order. I see Rory suggesting in the chat, if there's not a plan, how about going in reverse order? But I fear that that's going to be 4 hours of the last couple of days and not much else. So I think we will go in the main order, but we'll play it by ear and see how it goes. So before we get started, I'm going to go around the sort of array of panelists as I can see them, which might be different to how it is on the stream. And let's learn a bit about who everybody is. So start with Stefan Kruger, who...
Hi.
Hello.
Yeah, I work for Dyalog nowadays, but I kind of discovered APL once upon a time through this very competition. I remember studying Jay Fode's solution, actually, who's on the panel now, and yeah, it was a sort of crash course in APL, and I think, as Richard alluded to, the cool thing is that the nature of the problems, like read a bunch of data, do some weird calculation, and spit out a result is very suitable to APL, and I think we're kind of overrepresented sometimes in this challenge, so it's pretty cool.
Yeah, cool. Yeah, it's nice to have you. We sort of you wrote that book, Learning APL, which has been quite popular for people getting started, and the sort of appeal to people the way that you write and express the ideas, and now we've roped you in to being one of us.
Yeah, so it's the world's wordiest sort of employment or CV kind of thing.
All right, so next round we have Peter Vernogorov. I might butcher your last name.
That's
You actually
good.
reached out to us when we said we were doing this, right? Because you have been solving Advent of Code in APL for a little while now.
Yeah. So yeah, I started about 2020 or so. I started with J. I think I tried to solve that year in that language. Then didn't get much done, didn't get far. But next year, I saw during that year, I saw the beautiful solutions in APL that made more sense to me. Next year after that, I used APL, and I've since got back through all except for 1 year, completed them all in APL. That is unfortunately the only thing I can share in terms of what I've done with APL. I don't really use it at work.
Yeah, so you're an engineering manager for your day job anyway. You do programming
exactly
in other languages.
Yeah, that's correct. So I work at the Delivery Hero here in Berlin.
I see. Oh, that's right. Okay, yeah, I have here from our promo. You completed all the Advent of Code except the int code year, which was the infamous year of. Can I say the word ball ache? All right, we'll cut that. Let's move around. So thanks for that, Peter. So Jay Fode, ex-dialoger, former CTO, but
Hi.
long time Advent of Coder, relatively speaking.
Yeah, I've got quite a long history with Dyalog and quite a long history with Advent of Code. In fact, I think I'm the only person on this panel who has done a previous Adventures in Advent of Code webinar.
Yeah, we absolutely ripped the name from your webinar, unashamedly. Yeah.
Yep, I guess that means I own the rights to the format. So yeah, I just had a look back. I think I did that webinar in maybe 2018. And I was doing Advent of Code from about 2015 to 2022. I didn't actually play the 2023 series properly. You know, I had a look at a couple of the problems, but that was the first year in a long time where, due to the pressures of family and getting up at 5 a.m. and stuff, I didn't actually partake properly.
Oh, I was going to ask, because I remember at least, was it all the years that you fully woke up early and tried to get on the leaderboard and stuff?
Well, pretty much. I mean, it was a lot easier in the early days before it got really popular. You know, if you woke up early and had a good idea and got your solution in fairly quick, it was yeah, like I say, easier to kind of get somewhere in the overall competition. Then when I was doing it in later years, there were a lot of very, very fast people. So I kind of gave up on that side of it, but was still working through the problems each day, just kind of more for interest. And I don't think you mentioned, but there's a very active Reddit community. So during the competition, every day, there are threads on Reddit where people are posting their solutions and discussing the problems and stuff. And I think that's actually been very good for kind of visibility of, well, all kinds of languages, but languages including APL, because people are posting in one thread solutions in a whole bunch of different languages. And, you know, you get quite a lot of interest of people who've never seen APL before and suddenly start seeing these solutions pop up. And, you know, as usual, APL gets a bunch of different reactions, but quite a few people seem to be intrigued by that.
Definitely. I think that aspect of it we'll hear a bit more from with Aaron and Isaac, who I'm going to call on next, because I believe, Isaac, you've also tried to compete in terms of actually submitting when the problems are released.
Yeah, I think in earlier years, but as Jay said, it's much harder nowadays. Pro tip: if there's any like cellular automata problem or anything that you can use stencil in, you got a shot at the leaderboard. Okay. But yeah, I think I started with APL probably in 2018 because I saw Jay's answers on Reddit, and I've been competing every year since then. Yeah, I
and
go
also,
by.
Yeah, very nicely. Very nicely. You do post on YouTube quite a bit under your username,
so I go
Yernab.
Yeah, I go by Yernab on YouTube, Voidhawk on Reddit, and I wouldn't on Discord, just to make everything, you know, streamlined. But yeah, this is awesome. I think I've interacted with a lot of you in various contexts, but this is my first time talking to many of you, so very excited to be here.
Cool. Next round, we have Adám Brudzewsky. It's another dialoger. You're sort of known for, well, the APL Orchard. You talk a lot on the farm as well, or no, as some people call it, 24/7 Ask Adám. And you also did that video, I'm not sure how long ago now, some time ago, that was about parsing data using Quad CSV, because that was an approach that seems to work for a fair number of Advent of Code problems, or people were talking about that at some point.
Yeah, I don't know what else there is to say. And I'm kind of like behind the scenes a little bit. I never participated in Advent of Code myself. But yeah, I don't remember who it was, what it was that prompted me to make that video, but I guess I was in discussions with people and said, you know, all these ways to parse things, and we have some built-in ways to parse. You don't have to build up the parsing yourself. I've heard people saying that Advent of Code, like, it's mostly just parsing stuff. And yeah, I also do a lot of work on APL Wiki, and I've been maintaining the APL Wiki page on Advent of Code that has a giant table of known published solutions to Advent of Code in APL.
Yep. All right, next round. I think that's the last of those here right now. Aaron Su, you're largely known for work on the Co-dfns compiler, and this year you've had a fair stab at Advent of Code, it seems.
Fair, but a fair to middling. I think I was very proud of myself that one of the problems, I think part 1, I managed to get like rank 167, but it's a far cry from getting a point on the leaderboard. And I was chasing, I think, Rory Kemp's tail the whole time.
All right. But that was a Stencily one, wasn't it?
I'd have to look up. I don't remember which one it was.
All right. Well, we'll get to that. We'll get to that in a moment. But let's have one last little glance at chat. Nothing pressing. So I think, why don't we get started with a nice easy introduction where someone can perhaps share the screen. I have one up in mind, but you can speak up if you like. To look at day 1, we can sort of briefly introduce the problem and then maybe talk about how you go about solving it. So I don't know if Isaac, are you happy to lead on this? Aaron, do you have your sort of code and inputs available ready wherever it's needed?
Yeah, code and inputs, like what do you mean? I've got my GitHub repo published.
Yeah, but I mean, if you wanted to show anything or step through any code.
Yeah,
it doesn't have to be right now.
Show how I go. I could show how I go through some of it. You know.
But yeah, for day 1, I know Isaac, Jay, Stefan, I think you've looked at these, right?
Yeah, I'm happy to go through day 1.
All right, then.
Kind of do a warm up. Yeah, sure. Give me 1 second. Okay, is that coming through?
Yep.
Okay, cool. So yeah, well, I'll try and go through this like relatively quickly because I know we have a lot of problems that we want to do. But yeah, day 1 is let's see. So one thing about Advent of Code is there's a ton of flavor text, which if you're competing on the leaderboard, you will ignore or like filter out. But basically the idea with all of these problems is you get some text file with a bunch of input. And then as Rich was saying, you have to submit some text string, usually a number. For this one, we get, there's some sample input here, basically a series of strings. And we parse out the digit characters, so ASCII 0 through 9, And then we look at the first digit and the last digit in each line, combine them into a 2-digit number, and then we sum all of those 2-digit numbers for each line. And then let's see. So we can do this first. This is our test input. This is the part 2 test input, but we'll just stick with that for right now. This is quads and get test.txt1. And we take the first element. So we get these. And then for each one of these, for the we can just assign this to P first. So we have our problem input saved. Is this size okay, by the way? Is this coming through? Okay?
No, this looks good to me.
Perfect. Okay, and then for each one of these, we can find the we can get the actual digits that each one of these represent by using quad D and index of. So quad D just gives you an ASCII string of the digits 0 through 9, and then index of.
You're a quad IO 0 type person, huh?
Well, no, this is default IO. This is IO 1. I sort of switch it around depending on what the problem is, but I use IO 1 mostly because it's the default. I realize that's, you know, heresy to some people, but it is what it is. And then actually this is annoying because we have to do a -1 here.
That's why I asked, really.
And then we do a mod 10 to get the actual digits. So the idea here is for each line, we're putting a vector of digits. And there's zeros where there's no digit, and then the actual 1 through 9 where that matches in the string. And we can just call this like D, I guess. And then for each element in D, we'll put together a train where first we remove all of the zeros, and then we can take the last element with right tack reduce, and then first put them together like, hang on.
So I don't think you wanted that 10 residue, did you? Because that's losing the information about which things are digits and which things are not.
Wait.
I think
I'll caveat this with yeah, it is. I'll caveat this with I was expecting you to go get like the code you've already got and maybe step through it. I wasn't expecting you to go like live from scratch, but this is cool. We'll keep with this.
Yeah, fair enough.
Jay's got a suggestion.
Well, I think maybe you want to remove the 10s, not do the 10 residue and then remove the zeros. Yeah, because the 10s are things that were not digits in the original input.
Right, but I'm I'm removing the zeros here, so I'm doing. I mean, right, I guess you can just do.
But zeros also correspond to things that were actually a 0 digit in the input, which you don't want to remove.
Oh, yeah, but
are there 0 digits in this?
There aren't. So this is the other thing about additive code is that there's oftentimes problems where there's like some unspoken kind of rule about like some of the input, and you can oftentimes take shortcuts.
Isn't it easier, like Rory Kemp is suggesting, to just do an intersection with quad D on each?
Yeah, you probably can. I wish. Oh geez. Hang on. I could have used better preparation on this. I wish I could get this to. There we go. Okay. So yeah, this is the solution that I have. And let me just walk through this, and then we can talk about ways to improve it if we want. But yeah, so basically, so there are no 0 digits in the input, so you can do it this way. If there were 0 digits, I guess you could like remove the 10s or 11s if I wasn't doing subtracting 1 there. But the idea is that we're constructing a train here with F that basically removes, the zeros or the elements that aren't digits, and then taking the last element and the first and doing a 10 decode here to turn it into a 2-digit number. And then we sum all of them. And then, so part 1 is just running F for each line in D. And then kind of the interesting thing about part 2, and I saw on Reddit that a lot of people were using, regular expressions and kind of running into issues where you might have a word like this, which should be 2 and 1. I guess I should talk about.
So just explain part 2. Yeah, it's the same idea, but you can have the number words, the word version of numbers.
Yeah, so you can write out the numbers, 1 through 9, and then the idea is that those numbers should appear, kind of sequentially within each line, and then you do just like part 1, you take the first element and the last element, turn those into a 2-digit number, and you add everything together.
But it depends if it's the first or last thing, right? Because it can be the digits as well.
Yes. So
what's an example here?
Like this one, the first element would be 4, and the last element would be 2. And there's some other text digits in there in the middle that don't really matter that much. In this second line here, the first digit would be 8, and then the last one would be 3. And technically you have 2 there as well. So this is where people got tripped up a lot, I think, is that you have 8 and 2, even though they overlap. So you need to handle overlaps as well. So the way that I did this was I had this array in, which is just, boxed all of the digit words. And then we can use where to find.
I think that one's actually called find.
Oh yeah, find. To find where all of the words are in the inputs, and then we can do. I thought this was kind of cool. You can do an inner product here with iota 9 to get the actual numeric values 1 through 9, and you can sum them all together. And then if you add your original digits, we can just run the function f again to get the part 2 answer. The logic is the same, the first and last digits. So yeah, that's part 1.
That's part 2.
That's part 2. Yeah.
Oh, sorry. I mean, day 1.
Oh, right. Yeah. Yeah. So
maybe go back to the first part and try with intersection with quad D, because that seems like it would cut down the complexity a lot on the parsing.
Sure. So the idea is you want to do
quad D intersect each.
Well, no, you want intersection on the left of the quad D.
Like this?
Mm-hmm. Gives you just the digits, right?
Yeah.
And then just grab the.
I think the tricky thing with this is because you lose the spacing elements, it'll be hard to combine it with the text digits later. You know what I mean?
Yeah, one of the things that I've found when I've done this in the past is that if you're preparing solutions to publish, quite often you find that the way you ended up solving part 2 kind of influences the way that you would have done your part 1 solution. And if you're kind of revising it to publish it, then quite often I end up redoing part 1 in the light of that. So, I mean, I had not seen your part 2 solution. That's really neat, but it does kind of heavily rely on doing part 1 in the way you did it.
Correct. Yeah. And I should have prefaced with that. A lot of my solutions, I kind of go slowly and they're heavily revised after the fact. I think that's in contrast to Aaron. I know that your solutions were as fast as possible, completely unedited. So there's kind of a difference.
Yeah, a social experiment for me was to not do any post-processing of the code at all. It's just exactly what I was running with when I got the actual solution, with no cleanup.
But yeah, that is day 1 for me.
I
thought
like
that
the
was
inner product.
Yeah, it took me like a couple of years to actually start using inner products in these solutions, but once you do, you start seeing opportunities to use it all over the place. It's really neat.
I thought that was pretty tough for a day 1 problem, because if you do start using regular expressions for part 2 of it, you can go down this rat hole of, like, first of all, you don't realize that the numbers might be overlapping, and then you come up with various ways of kind of hacking around that and trying to make the regular expression thing work despite that.
I'm really curious how many people got part 2s to work using their first initial idea of how to solve part 2. Like, I think every single time I made some kind of false step after day 1, every single time I tried, the first thing I tried always blew up on.
Yeah, yours look quite different. Do you want me to share yours, Aaron?
Mine are actually pretty close to Isaac's. Well, actually, I guess they're a little different. It's a small copy. It's up to you. I want to also see other people's solutions as well. I'm here to vicariously see everyone else's.
I used the intersection trick, but then for the second one I did a mega regex to just transpose everything into a format and then run it through the same thing again. Yeah, and that worked well.
Yeah, let's have a look really briefly at this. I think the one thing that intrigued me about yours, Aaron, was this little loopy replace construct here to take.
Yeah.
So you do the finding. I mean, this is like the outer product find that we just saw, but then you sort of use that to literally just drop in, replace the digit, the first letter with the digit, and then then literally do the day 1. So that's kind of neat.
Very hacky, but it worked.
Okay, cool. Anyone else keen for anything to share? Anything substantially different or interesting, or should we go on to another problem?
I had the same solution with find and everything else. My only kind of note here is that usually there's I noticed that with some operators like find, which is the E underscore, or index interval, you get like one puzzle in the whole month, in the whole element of code of the year to get to use it. So for find, that was the only use for find in the whole of element of code 2023. Day number 5, for example. It's a sneak peek, but that was the only usage that I could find of the index interval. So
I think I managed to use it on day 11, but it probably wasn't the best way of doing day 11. Yeah, cool. So, sorry, I'm just checking chat. I believe the next one that I've got on my list, day 3, is I think the one where, Aaron, you said maybe in an email that you got close to being on the leaderboard. And
just on day 1 or part 1.
Part 1, right?
Yeah.
And this is also where
went to pot.
This is also where sort of stencil begins to rear its head. I don't know if I can. Does anyone else have comments on day 3 while I try and load up enough to share something interesting for Aaron to show?
Yeah, I thought day 3 was interesting. At least for me and my solution, I found it very useful to work with the input in both kind of like vector and matrix forms, kind of, depending on different aspects of it. So I thought that was kind of neat. But yeah, stencil's incredibly useful here.
If I just get the example thing, then I can hope. Right, I'm going to share this, and Aaron, you're going to have to talk me through because your inputs are not just the text. Sometimes you're mixing them first, right?
No, the first thing I do is I copied and pasted a matrix, a character vector matrix of the puzzle input. That was my thing. So
So what's this? It's trying to remember to explain the problem.
So you have these numbers that are adjacent to specific symbols.
That's right. So we got these part numbers. So here we have this asterisk, and surrounding it in the grid are number 7, number 3, and number 5.
Yep. And so these numbers are considered sort of the adjacent digits form whole numbers, and then you have to sort of add up all the numbers
that
are adjacent to a symbol. And so part 1 was, oh yeah, this is easy. This is going to be great, right? Because you apply stencil over it to get. Now, as a practical thing, I'm sort of philosophically opposed to the stencil operator, so I'm using the stencil function principle here. So that's why you'll see me only what the.
Don't worry, that's me getting you the matrix. Like I said, because you're not taking the raw text, you're taking this text matrix.
Yeah. So
that's
I use the stencil function. So I get basically this cube of, or actually quad. I think it's the matrix size with the windows replicated. So the shape of that should be something like whatever the shape of the text is.
Yeah.
And the each of the sliding windows.
Right. So these are our sliding windows.
Yep.
And wasn't anything important, right?
So once I have those sliding windows, I can just look for the things that I want in my setup. So each of these windows, I'm either looking for digits or dots or spaces.
I see. And when you all reduce twice, you're going to end up back at your
back at my 10 by 10
original shape.
Yep. And that sort of gives me my adjacency setup that I want. And then I take a mask over that by only looking at the digits.
Maybe mine's too large.
I think you should split it horizontally, the debugger on one side and
this over here. Okay, that combined with Zoom share.
Okay, never mind.
Has made I think docking combined with Zoom share has not been.
You can't duck the window while Zoom is making an overlay on top of the screen because you can't pick up when you're hovering over. Zoom is inserting like a layer in the windowing composition system, so it doesn't detect drops of windows into other windows.
Okay.
Interesting. Whether that's going to work.
So
it does. Nice.
All right.
Okay. Yeah. So your things that are adjacent to symbols.
Yeah. So I get this sort of mask of my adjacent things, and then I use it with a partition to extract out and split these things into these sort of objects.
Yeah.
Each of the numbers.
So this is where we're going to vector town because because you're using the whole mask to get out the numbers from each row or from the whole input.
Yep. And then I use the same mask on the adjacency matrix to get the sort of our filter of the relevant numbers, and then just go from there.
Yeah, makes sense.
Yep. And so then I thought, oh, great, not too bad. I'll do part 2. And of course, I got stalled on part 2.
It's the same input.
Yeah.
Makes sense.
And the challenge here was everything seems simple, but the subtlety is that my part 1 assumed that we were extracting neighbors on the basis of the gears. And the problem here is I had to invert that relationship and look for numbers with gears next to them rather than gears with numbers next to them.
Can you explain what the problem is?
So yeah, that's what I'm going to now. So the gear is any asterisk that's got exactly 2 numbers adjacent.
Yeah. So basically, in the first part, we were just looking for any type of adjacent stuff or non-adjacent stuff. I forget which one it was. And then here, we're looking for specifically a specific type of adjacency where the numbers are the key element here, which is the fact that there are only 2 numbers.
Right. Like here.
Be next to it.
Oh no, that's not. There's a 9 there.
Yeah, so that one's fine, right? But that 617 is not included because it's only adjacent to 1 number with 617, whereas the other 2 are adjacent to 2 numbers. Oh,
that's right. Oh, so we're considering the whole.
The whole thing.
It's not just digits now, right? So
it was never digits.
Oh, yeah. Okay, my bad. Misremembering. I see. And so here we've got 3.
Yeah. 2. So the challenge there is you have to identify. You have to have some mechanism by which to find which ones only have 2 adjacent things next to them. And I got stuck on that because I needed to figure out a way to also identify which gears belong to which adjacencies. So in my part 1, I didn't have an easy way to answer the question of, these 2 numbers are adjacent to which gear. And so I had to come up with a solution. Now, I'm pretty happy with the way I calculated gears here. I kind of like this expression where I sort of map this into the shape of the index and then just mask over the stars on that space so that I get the same shape, but only the relevant numbers. And then I just take maxes over those. And that gives me the relevant adjacent gears in any given index in the space.
So that's here. You've got, that's like a J style iota, right? And then masking those indices in a linear sense.
Yeah.
I don't know if that's obvious to people watching.
Yeah, so every gear gets a number, which is its position in Ravel order.
Yeah.
And then by reducing these using max on the 3x3 stencil, every cell essentially gets to know what gear is related to that cell or adjacent to that cell or within view of it.
Should put some quad getters in here. Maybe that's the easier way.
That's what I do. Every time I was working on these problems, I just put a bunch of prints to see what I was doing.
Oops, wrong way. Doesn't matter. Now I'm just being a bit.
Now you're just being. This is actually something I noticed. It was really, really, really tempting to do more than what was necessary for the problem. Like this is but I mean so then we use the same masking technique to mask over the gears to get their numbers, and using that same mask with the same technique to get the numbers themselves. And that allows me to map and create a map between the gears and the numbers that are associated with the gears. And then I use this horrible hack of a key to do the addition.
So why is this
I'm not
so
proud
terrible?
of that line. I'm not proud of that line at all.
Oh, did I miss where gear num came out? Oh, that's these.
Yeah.
These are the keys into our numbers here.
Yep.
Ignoring zeros, fine.
Oh, it hurts. It hurts. Yeah.
And okay. And then when you've grouped them, if there's 2. Oh, if there's not 2, then you don't want it. Otherwise, you want the product, which is what the
Right. So we produce
final
the
solution
product of the
asks
gear
for.
ratios, which is the pair of those numbers, and then we add all of those together at the end.
Okay, makes sense.
Yep.
Cool.
This is a pretty hard problem for day 3. I thought compared to previous years.
I think that was our advantage, right? That's where if you had stencil, you can sort of kludge your way through it in a similar way that you do with the early problems. Where you...
Yeah, I'd say the first problems gave me a very bad false sense of security, false hope. So, yeah, but I don't know. I think these are actually pretty. If you're an APLer that you've got some experience, the APL primitives give you a lot of tools to tackle these kinds of problems very quickly and easily. I can imagine this could be, if you're not a pretty experienced hacker, you're like doing some of these in other languages. If you don't really know your libraries or really know your algorithms, like you could spend a lot of time trying to get the little details right on some of these little primitive operations.
I got the impression that's what people did, was build up either knowledge or a specific sort of set of tools that they know they're going to be able to use for advent of code.
Yeah, I would expect if you're going to try to come even close to competitive on this, you would need to do something like that.
Isaac, you mentioned before about using the matrix in some case for this problem and using the vector in the other case. Was that pretty much addressed in what we just talked about, or was there something else you wanted to share about that before we go on to, I think?
No, I think that's
day 5.
That's the general idea. I think there's like with a lot of these problems, if you know what part 2 is, you can kind of structure, you can put together a data structure that can be used for like both part 1 and part 2, but obviously you don't know what that is ahead of time. So
did you find yourself trying to anticipate what part 2 is? Like, all right, if I were going to try to make this hard, how would I make it hard so that I can do part 1 in a way that's going to set me up for part 2? I caught myself doing that.
Yes, I think if you're straight going for leaderboards, oftentimes I don't do that. Like, I just try and get part 1 done as soon as I can. And then even if I'm not going for the leaderboard and I'm trying to anticipate what part 2 is, sometimes I'm wrong, and that's unfortunate. But it certainly does help sometimes. Yeah.
You can usually tell sometimes from the language used in the part 1 as well. If part 1, especially in the later days, seem to be a little bit easier than you expect, then you know that part 2 is going to be, now do it 1,000,000 times. Yeah.
Yeah.
There was definitely a couple of those.
We have a question. Sorry, we have a question in chat from Rory Kemp saying, could be wrong because I haven't tested, but would your partition solution fail if one line ended in a number and the next line started with 1?
For day 3?
That was my fear as well. And what I did was I just checked the input if that's the case. But I also knew that I could just prepend an extra 0 or something, or an empty whatever, and then it would work fine.
Yeah, that was the case for my solution as well. And if you just put, like, you can just put a period on the end of each line in your raw input, and it's just fine.
Right. Yeah.
That's the kind of thing that it's really good to kind of know as you're doing the solution that that's a potential problem, because if you try your solution and you get the wrong result and then you're reduced to trying to debug it, it kind of, kills your speed.
Yes. Very true.
In fact, well, I mean, when I was doing it competitively, I pretty much had a rule that if I ever got into debugging, I might as well give up. By the time you've got stuck that much, there's no point trying to get on the leaderboard.
I think another thing that's interesting with these kind of problems is that usually you can shortcut a lot of complexity by looking at your data. If you're just eyeballing data, because you only need to solve for your particular data, you don't need to overgeneralize, right? So if you eyeball your data and see that it doesn't have a certain character in it, or whatever it is, like if it doesn't end in a number, you can sort of say, okay, I'm gonna just focus on my particular data set, even if it's not a general solution. Yeah, it's just a matter of solving it for your particular data set.
Rory agrees. It was Rory Kemp who posed that question about it could fail on if one line ended with a digit and the next one, or ended with a number and the next one started with a number. And he says, yes, of course, you could append an extra dot or something. So, Isaac, I know you mentioned day 4, but I'm actually going to skip over that. And because I think a lot of people had tackled day 5, which is quite interesting for a couple of reasons. Yeah, who might be willing? I mean, Peter, you alluded to it, I think, in your introduction that this is, or no, a moment ago, that this is a chance you got to use interval index. Oh, and Jay as well. Did you tackle this one? You mentioned in your email, Jay, that this was a specific one you were going to look at. Or...
No, I had heard that someone had asked about it, but no.
Yes.
I haven't looked at it myself.
So I don't know if he wants a shout out, but Steve Allen in the APL farm did actually request that we look at day 5.
Cool. Yeah, day 5 was probably one of my favorites because of the index. So
are you able to? I don't know if you have the problem description page open as well. We could start by just.
Let me do that.
Briefly introduce, what it is exactly.
Meanwhile, while he's finding that, makes me nervous with all the executes everywhere. Please don't do this in production code, only if you're trying to be short or fast.
Oh no, were you gonna bring up Rodrigo's question? While we're waiting. Yeah, go on briefly. Aaron, Rodrigo asks, is there going to be a t-shirt edition of AOC 2023? I mean, to be fair, if you look at the...
That's a good idea.
Let me paste it in chat, the link to your GitHub. So then people can see just...
This is a very good idea.
How much might fit on a t-shirt.
I think we might have to do this, except some of that code is so embarrassingly bad. Is it t-shirt worthy? I don't know. Could be fun though.
Will it be worth cleaning up? So, right, problem 5. Something about seeds.
Yeah.
As usual, we gloss over the bulk of the text to find the highlighted words.
Yeah, I usually read the story, not this year, but they're usually fun. But yes, you have the seeds that you start with, and then you have the mapping from one to next, and it's consistent that it's going to be in the right order. Though that doesn't, as part of the input, of course, that was the case. And I don't remember actually what you need to do here. Does anyone remember?
Yeah, you have to eventually map your seeds to locations and then look for the lowest. But
so if you scroll up a bit to see the top of the input, you've got these seed numbers. And then the next part says seed to soil map, and it says if you've 50, was that 50
I think
up to 98, then you plus 2.
No, it's 50 and 98 are the start points.
No, sorry, I was
destination.
Yes,
and the length is the third digit.
It's confusing because I was adding 48 to 50 in my head there. But the next number above is 98. So if you start from the top row, that says if you're 98 or 99 as your input, then you output 50 and 51. And then the second line of the seed to soil map there says if your input numbers are between 50 and 97, because the length is 48, then your output numbers, those get mapped just +2 to 52 to 99.
I think it's something like that, yeah.
And then the next step is to do the soil to fertilizer map. So you take the output from that first mapping, and then again you have these sort of, yeah, your source number, they're called 15, 52, 0 in the middle column. And if they're from that number to that number plus the numbers on the right-hand column, that's the range length. It's annoying because I swear the first thing, I don't know if anyone else did this, so the first thing you try and do is just like rationalize these mappings into something a bit more, you know, sensible,
Yes,
like
I
something that works
did
in your
that.
head. Because here, just, yeah. Okay, start 15, length is 37. So that's 15 plus 37 minus 1. That's the last number it can be. Blah, blah, blah. That was a terrible explanation of this problem, but hopefully the idea comes across. One thing that I didn't actually manage to implement, but I noticed, was you can also think of these mappings like a kind of stepwise function, or it's a linear, it's a y equals x, except for in this range, you sort of add a number or subtract a number if you plot these out like these functions with a step in it. And so one approach that I think is possible is to take all of these maps and merge them all together. Basically take all those functions and join them. And then you have a single lookup, basically, or interval index thing. But I don't have code to show for that. It's just an idea. Sorry, Peter. That's the...
No, that was good. Because now I remember what the three columns were. Good. All right, if I then share my code. So hopefully the colors are not too confusing, but the general idea is to read the input, break it up into groups. So this is what I do usually for situations like that. I use the, you'll have to excuse me, I never talked to anyone in APL, so I don't remember the names. I know how to type them, but the signum, right? The signum operator, which will tell us if the length is positive or 0. So that will break it up into empty paragraphs or by paragraph. So that the file is basically an array of each block of that input. And then for each one, the seeds, obviously, which I denote as S, are just basically, eval. I know Adám is not a big fan, but for Advent of Code, that's the default usually. That one's pretty straightforward. And then if I jump to the, all right, and then M is basically a matrix of actually processing all those what are they called? Mappings, right? So that's the M is for that, and essentially it's remove the first line of each one where it describes the names, they don't really matter, evaluate the numbers, do the flip so that we can just have the destination, source, and the length, right, of the mapping. So it comes from the source with the length and the destination is where it's going. And that's the majority of work to get index operator thing working is actually here, where we create the bounds and distances separately, and I use the -1 so that there's always something that starts in the beginning so that the index range works correctly, and there's always something. There was a lot of debugging involved to get it to work, and of course minor thing maybe, but I needed to sort it obviously so that the source, it's sorted by the source, so that because to get the index range operator to work, the input needs to be in a sorted fashion. I don't know if we need to go into this, but essentially produces the two items for each mapping. One is for all the sources, all the bounds.
So is that for any of those lines, the mappings, is it like the first number to the last number that would trigger that transformation?
Yeah, what I usually do to read back what I have just print and maybe the first one. Right. So if we remember of the input for the first one is starts with 98, ends with 2, length of 2, and mapping is to 50, obviously from 50 to 52. So then the bounds starts with negative just to get the something in the beginning, and then 50, 98, 98, 100. So that's the range that's involved in. Oh, sorry, the 50 here is, of course, coming from here, right? So the first range is actually the second line, right? 50. So we start with 50, and the block of that mapping is 48 of length. So that's why we end up with 98. And the next block is from 98 to 100.
But 98 is sort of outside the bound. No, does it not go up to 97, or am I mistaken here? I understand it will work for your solution. I mean, in terms of like which numbers, if a 98 is in the input, it's going to go into the second.
So what this allows me to do is, given this input, I can use the index
interval index.
Thank you, index interval operator, to just pass it in, and it will tell me which range it's in. And if it's odd or even, it will tell me if it's within the outside the thing or inside. So if it will be in here, right, then it would be outside the bound. This one is inside, and etc. And then once I know which mapping it's in, I can apply the mapping, and the mapping is essentially the length to move it by. Right? Yeah. So for example, if I land in 99, then it's in here, and then I just, for those ones, I just remove decremented by 48. For anyone outside the bounds, nothing happens. It's just a 0. And that's, so that preparing the input in such a way allowed me to use the index. Forget it.
Yeah, that makes so much sense. And now that explains why I saw the 2 mod in Aaron's code. That I was wondering what that was for.
And then the rest is quite simple. For the first one, it's a matter of just I have a mapping function which basically does the operation I just mentioned, which given the bounds and the distances, it returns the new number, the new numbers from the range, and uses the index range operator essentially and maps it into the distances that I need to apply, and increments it by that. And it just does a range, a join, reduce in reverse order, and then it's a matter of finding, I guess, the minimum was the question. For the second one, I needed to implement a splitting function. For the second challenge, what was the, sorry, for the second part of the challenge?
The second part could be construed, as Stefan put it, as now do this a million times. But obviously, that's actually not the way to do it. You basically, where in the we can you swap over to the problem description?
Yep.
In the first part, you've got the seeds. So you've got 4 numbers there: 79, 14, 55, and 13. And you just need to take those exact numbers through each transformation through the mappings. The second part says, no, these are actually 2 pairs, or the 2 ranges of numbers.
Right. The first one being 79 and then a length of 14.
Right.
And the second one is 55, and then the next 13 numbers.
So you could imagine, in a naive way, of just generating all of those numbers from the ranges and then putting it through the same thing. But of course, the puzzle input they're going to give you has hundreds of thousands or millions of numbers in those ranges. So you basically get a workspace full. So you have to do something a bit.
Exactly. So you can't just look at them as individual numbers. You have to work with ranges. So I have a splitting function, which what it does is, given a bound, which is the first array that I have here, we need to basically split it up into a new range. So given a particular range, I can split it up into multiple ranges. So for example, we had in the first one numbers from 40 to 90. It would split up this range separately. Because part of those numbers in my initial range would fit in the beginning here in the first interval. The second part of my numbers will fit into the second range, and then potentially into other ranges. So I needed to create new ranges that I'm working with.
Yeah, how does this? We'll just stare at it for a minute. Or maybe we can take an example of a range coming in and a range coming out.
So given a range, which is
oh no, sorry, it's not. It's a 70. So would you convert, for example, that 74 and 14 from the example? What do you convert that to, or what? How does that become a range? Is it the first and the last number? So 74, 88.
Actually that in here. So we'll split. And let's take the original, one of the example inputs. So assuming there's our range and the bound, and then the range that I have now is from 40, and then I forget how I represent ranges. Oh, okay, so it's inclusive. So from 40 to 90. So this will create two new ranges for me. So instead of 40 to 90, I have 40 to 50 and 50 to 90. And the reason for that is because the first range will be in the outside the first kind of bound, and the second range will be inside inside this bound.
So in the middle there, your reduction smells like dfns 2 or whatever. It's a range maker. Is it the alpha plus 1 plus iota omega minus alpha?
Yes, I usually include the iota, all the other functions actually from the dfns space, yes. But when I clean up, I either replace them or
no, of course you don't need everything that 2 does. You just need to say, what do you get there? You just need the 40 to 50, 50 to 90.
We can actually build it up. So,
but it's not though, is it? Because it's the intervals.
So at first we know that we're in range 0 and 1.
Right. The first one is between -150. The second one is between 50 and 98. So
right. So
index
iota
origin
here
0
is actually not for the numbers themselves, but for the ranges, so for the bounds. So I know that if I rebuild it exactly, so I know that it's just the one. Did I miss something here? But essentially, these are these are the these are the bounds that got matched by the range that I have. And then we know how to split them up based on the logic here is a little confusing to me, but now that I read it again, but even though I try to write in a way where it's kind of clear, I actually have no idea why I have iota here.
I did almost the exact same thing here, and the reason why I generated a range there is because, like, so if you do interval index on your range and you get like 1 and 5,
that's right.
The idea is you need like 2, 3, and 4 so that you can index into it, and then you can put together the new ranges, right?
So if your example instead was 4099, then that's going to span 2 sets of bounds. So your interval index isn't going to say, what is it, 0, 1, 2. It's going to say 0, 2, but you need that 1 in the middle to get the 5098 range in the output. I hope other people watching have got this as as much.
This is a pretty subtle thing if you don't work with like ranges a lot. And to understand where the cutoffs are and how they lay out, like it's easy to get it wrong. I spent a lot of time myself trying to think about how to normalize these ranges and do splitting.
Yeah, your
mine
to
shows
call you out, your code's a lot longer.
The horror of a broken mind.
Let's see it. It's because I think we've got the gist of it. I'll share. I'll share. I mean, I'm laughing. I didn't finish it. What was this? 5. And I guess, well, we'll see both of them, won't we? Part 1, you think not too bad, kind of comparable in a lot of ways.
All good on part 1, but then to manage the ranges, I do a normalization, which is essentially the same splitting process. But you can see I kind of have my normalization essentially tries to align all the ranges up so that you don't have crossover or overflow. And so that's where I run this fixed point where I keep continuously splitting until I get to the thing that I want, basically. And it's nasty. I don't even know if I could adequately explain it in the time. But it's the same basic structure, which is that you have to look stuff up, and you look stuff up progressively through the maps. And inside of each lookup, you got your source and your destination. And in the lookup, right, I apply this normalization function to the map that comes in and our current ranges of where we are in our current ranges. And then what I get out is sort of like the sets of beginnings and ends of all of our ranges. So I kind of do more than I ought to, because I could prune which ranges are valid right now, which aren't, or potentially something along those lines, but I don't. So I just compute all of them over all the ranges. And that requires me to start like doing this horrible thing, because I couldn't break it into my head fast enough to get the clear picture. So this is, by the time I actually got it to work, this is what it had looked like.
Yeah, I spend a lot of time on the surprisingly on errors, off by 1 errors.
Yes.
With the ranges, and I kept switching between, is it inclusive range? Should I represent it as exclusive? And that took a long time as well. It was a lot. It was
so painful. Yeah. So I normalize my maps to you can see to these sets. I think they're cubes of 2x2s, where the 2x2s is the beginning and end of the source and the beginning end of the destination. And that's on line 1 of this function. So when I set up my maps, that's sort of what's coming in.
Got this one. Is this another, or do you do the actual parsing this time? No. What am I supposed to give?
You need to give it the matrix form of the puzzle input.
So literally just, again, you just always give it.
It's always the matrix form.
Text matrix. Okay, yeah.
Yeah.
So something like this.
Yeah.
See if it's what. What am I missing?
Is it the matrix format? Yeah. Okay.
Is it because we're missing? Oh, because I've done a split on new lines and not. Is it because I'm missing an actual line between sections? Do you need that?
Oh yeah, you need the blanks between the
the
lines.
Okay.
It relies on that. Sorry. I usually just would copy and paste in a matrix in the form. So I would do like I just do e.g. gets table of the ravel of the space. Yep. And then I would edit that and then copy over the puzzle solution.
You know, I was gonna, and potentially would do this.
Make sure you don't have the blank at the end, though. You need to make sure you don't have.
It seems like it doesn't.
Okay,
but you can actually do this directly as well.
Oh,
So
yeah. I was going to suggest, because I saw Peter's setup is kind of interesting. Maybe we could do a little tangent about workflow setups, because I saw Peter, you have like a Sublime text plugin, and so anyway, we'll get to that. Go on.
If
Adam.
you erase EG,
yeah,
and then I mean,
or
really,
maybe I'll make this EG5.
Whatever. Yeah. So, but then if you well, I don't like using system commands, but let's just use your system command for now. Yeah, exactly. But you can use quad ed as well. So if you write quote minus quote.
Oh yeah.
Quote ed and then EG5 or whatever you want. Then it's an empty matrix from the beginning with no risk of
That's
having
right.
that
It's very nice. I do often forget about the left arguments to.
And if you use paren ed, which in this case saves you some typing, you can write paren ed minus EG5 directly.
Yeah.
No space even.
No space. No space.
Like
Yeah.
this.
No,
well,
no.
you want after the ed, you want the space, yeah.
One space only.
Yeah.
Okay.
Yeah. Yeah. Okay.
Cool.
Yeah. So that should be the.
Right.
A bit easier than making it. But also, why did you revel the space?
Just to guarantee that I got what I wanted.
What?
What are we looking at?
The table function always returns a table. Wow.
Yeah, okay. Similar thing there, getting your destination sources and the range lengths.
Yep. So I normalize this all into beginning and end forms.
Yeah, I'm curious about this. What's omega? That's the input, except for the seed? No. Oh, sorry. Right.
Yeah.
Oh, so it's just the seeds except for the word seeds and the colon.
Yeah. And then I just take those digits or those numbers and compute the beginning end ranges.
Oh, that's right. There you go. So those are your inclusive ranges, right?
Yeah.
That we can see. And this is done as a matrix, whereas Peter.
And maps should be the shape of maps, I think, is a vector of cubes. Yeah.
Yep.
Ha! I remembered it. Barely.
So if we take, oh gosh, I wonder if we can translate.
Yeah, so our seed to soil map is 5098-2. And you can see in our map, you've got 50, 52, and 98.
So you're saying you can take as an input number 98 to 100 exclusive and 50 and 52.
Yeah.
It's hard because the way that the first example overlaps the ranges, but no, that's a lie, isn't it? Because don't you take your input is between 50 and 98? Oh, is each one an input then the output?
So yeah,
right.
Yeah.
Yeah. So takes in numbers between 50 and 98, outputs numbers between 52 and 100, basically adding 2 in that case, and subtracting 48 in this case. I see. Yeah. How far are we going through this? So we don't have to.
I don't know that we have to go very far.
You've explained a lot about it already.
Technique. Yeah, it's the same basic technique. It's just much worse code. So maybe I have to sort it, normalize it, do all that kind of stuff, and then once you do the actual lookup, it's just you basically all that work to normalize it to the beginning and ends. It gets the length and everything. Then all you're doing is an interval index into it.
Yeah, and then
looking for the groups that count, and then updating the ranges to the new ranges.
Maybe just day 5 on the t-shirt, Aaron.
So that we can have a t-shirt burning ceremony. Yeah.
All right.
So I like I think Peter's solution much more.
Yeah.
To be fair, I did clean it up a lot. It was probably as messy as this.
As this? Maybe. All right, fair enough. Cool.
And I think I found myself kind of struggling a little bit because I got mixed up on whether I was actually working with vectors and nested arrays or whether I was working with higher order you know, or higher ranked arrays, and they kind of both were living in the same space, and it just it didn't work.
You can see that you want to, and it should make sense because
I just
everything's
needed to
kind of
commit to
regular.
one direction or the other, really, but I didn't. I was too pressed for time. That's what happens.
I see. Yeah, as you said, that's a nice caveat there. Right. What I suggest is maybe we take a little break in a second. And then, so what do people feeling? 5 or 10?
Let's see. Well, we've done 5, which
I was going to go on to problem 7 next. I meant the number of minutes in the break.
Oh, okay.
To make it until 25 past the hour, assuming your time zone is.
Yeah. How long do we have left to do stuff? Because
We've got ages, but we're under no obligation to use up 4 whole hours. You know, I sort of put that there as a, you know, because I know it's very possible we could easily fill up all that time.
I'm happy to keep going in on any problems that people want, but I do want to make sure we get other people's problems too. Does anybody have one they want to look at in particular?
So on my list here, I know that we've got 7. Isaac said was pretty fun. It's the card ranking one. And day 9 you had something clever and mathsy. Day 10 is also clever and mathsy, but Stefan might be able to talk a bit about day 10, which is is it the pipes one that you're finding like this sort of circuit around some pipes? And then we start to get into heavy days. But I suggest I think 7, 9, 10 as the next lot before we start to get into parts where it's basically I think only Aaron and Peter will have loads to say. So yeah, right, 25 past whatever hour you're currently running on, unless you're in a weird time zone that does half hours, but let's not. Yeah, get them a stretch your legs, and then we'll come back and get back to it. Sound good?
Sounds good. Sounds
All
good.
right.
Okay.
Sounds good.
See you in a bit. Okay, welcome back. Only a minute later than we said. That's fine. But to the schedule. Next problem we're going to be looking at is day 7. So Isaac has kindly surrendered as volunteer victim.
A volunteer's tribute.
Other people have solved this as well. So we've had, I think, Steph and Aaron said they could chime in, but you're going to be sharing the problem, and I guess your code is the main focal point.
Cool. Yeah, is the screen share coming through? Okay.
Yes, we can see.
All right. So yeah, in day 7, like all of these, there's a bunch of flavor text, but the idea is that you will have a series of hands of cards, which, if you are not familiar with a standard 52 card playing deck, you have numbers 2 through 9, and then 10, Jack, Queen, King, and Ace. And they are in the strength of each card is in this order. And then each hand of cards, you'll have 5 cards in a hand, and they get some sort of ranking depending on what combination they are. So like 5 of a kind, 4 of a kind. Full house is like a pair, and 3 of a kind, et cetera, et cetera. And then the idea is that we are going to be ranking our hands by the strength of their hand first. So determining which category it fits into. And then within each category, we will break ties by the strength of the various cards, right? And then additionally, each hand is assigned a numeric value. And the numeric values are multiplied with their ranks. So like I think the least powerful hand gets rank 1, and then most powerful gets, rank number of hands. So you multiply each hand by its number, and then you add all of them together to get your puzzle answer. So there's basically this is sort of essentially like a sorting problem, is what it boils down to.
Yeah, go on. I know. Yeah, it's coming back to me now what was going on when I looked at this. I think I tried to come up with some way of signifying what kind of hand each was, and then giving that a number based on the ranking, just multiply whether it was that type or not.
Yep.
And then you end up with an inner product at the end. Is there something along those lines?
Something along those lines, yes. Yeah, so we can just do some parsing first. Basically, I kind of parse it into this 2-column matrix where on the left side we have all of our hands. And then on the right side, we can parse all the numbers, and we just get the bids. And then I also come up with the ranks, like so. This is just sort of the relative strength of each hand using quad D in place of all the digit characters. And then in terms of the hand ranking, I have this function f, which we run it on like the first hand will give us some number here. The way that f works is essentially each one of these categories is you could hard code these, but actually all of these boil down to kind of the counts of the number of cards that fall into each group. So you can use the key operator to sort of count the number of elements in each group. So it's like 5 of a kind, 4 of a kind, and then full house is just 3 and 2, right? And then you have 3 of a kind, which implies that it's going to be 3, 1, and 1, and then 2 and 1 like this, right? So you can get away with not having any information about the hands at all. The only thing that you care about is the count of each group. And so that's what we do with the key operator here. So this just looks at the length of each group, and then we sort them descending, and we take the first two elements of the group counts, and then this 10 decode is just a cutesy way to put them together into a 2-digit number. So like 5 of a kind would have a 2-digit number of 50, and then 4 of a kind would be 41. Full house would be 32. 3 of a kind would be 31, et cetera, right? And the nice thing about representing them all as these 2-digit numbers is when you sort them, they exactly correspond to the hand strength.
Oh, that's cheeky, that.
Yeah, so we can get we can do this for each one of our hands, and we get all these 2-digit values that correspond to the.
So what's this? The 3, 4, 2 Queen King.
Yes.
1-1, just high thing.
Yeah.
Right.
So,
it isn't until you hit the 2-1. It's the 8, 5, 6, 6, 3. That's one pair. Is this right?
Yes. Yeah. So it's like it'll be so a single pair would be 21, and then if they're all different, then you get 11, right? Because the first two groups will have a count of 1, and then it's basically high card. So after you determine the hand strength, the next thing that you need to sort on is the strength of each individual card in order to break ties within a particular category. I have this function G, which let's see, what does this do? Oh yeah, so G takes a ranking on the left side. For part 1, our ranking is 2 through ace for the problem description. And then we find
what's your B there?
Sorry?
B times the ranking.
Yeah, B is the
oh, sorry, yeah.
I'm
back. Yep.
Naming things is hard. Okay.
No, good.
So
actually, it's the same as my B that I'm looking at on the other screen, so I don't know why I asked.
So within this, we take the ranking for the particular problem that we're looking at, and we find the index of each one, and then we sort of we kind of construct a matrix here. Maybe I can. So if I look at so if we do something like this, you can see. So basically, the latter 5 columns of the matrix are the index of each card within the rankings, and then the first column is the strength of the hand per the key operator that we used before. And putting things in this way means that you can sort using I think you guys have total array ordering or something, but you can sort the rows of the matrix, and it will consider the hand strength first, and then we'll consider each card in turn. Right.
Yes, Jay and Adam, I think, were both pretty instrumental in putting total array ordering, although I don't know how different that is to, we'll do before then. You could presumably still, could you order the rows of a matrix?
Yeah, this is just a simple numeric matrix at this point, isn't it?
Yeah.
So you could have done that before the total array ordering.
I was just trying to hype you guys up. Okay, this works with strings or whatever else. It's great.
It's true though. I can't think of a specific, but once or twice there's been different coding challenges where the fact that you can order any type of array in APL comes in pretty clutch.
Yeah,
it's a pretty nice thing to mention, even if it's not technically in this case. But yeah, sorry, go on.
Yep. Cool. So we basically sort it, but we do this double grade up, which we'll I always get a little bit confused by this, but double grade up will basically tell you for each of your original items what the rank is relative to the other items, right? Like a single grade up.
I always think of it like if you had some scores and then you were putting them on a podium.
Yeah.
it's
that operation is called rank, isn't it?
It is confusingly. But together with the two other concepts that, well, one related concept called rank and its partner operator that also called rank.
So both row and grade up are known as rank.
Should do something about that.
It should be tally row, not row, but yeah. And I've been thinking that maybe we should add a monetic function that gives you the rank directly. It's kind of fundamental, just like the depth.
Yep. But doing it this way allows you to multiply by the numeric bid values without having to permute it or
right. And you're so close there to another inner product, but it's fine. I think. Oh, maybe does it not work in your arrangement?
Yeah. So yeah. So for part one, this is basically just, you know, if this is, let's use our original formulation of G here, where we sort everything, multiply by the bid values, and sum everything. So for part one, it's basically for each hand, find the hand ranking, and then do the sorting, taking into account the rank for part one. And then part two is slightly different. So first of all, the card rankings change so that jacks are now the weakest. Jacks are now jokers, apparently. So our card ranking changes slightly. And then the idea is that jokers can stand in. They're basically wild cards, so they can be anything, any other rank. And the idea is that given that we are supposed to find the strongest possible hands that a particular row could represent using jacks as wild cards, and then do the same sort of calculation. So for me, that looks like this. So the way that I did this is I basically use like an outer product where so R has all of our possible rankings, and then so we do an outer product on each one of our hands where we basically substitute J with each one of the possible card values, and that gives us oh yeah, and if I omit the hand strength calculation, you can sort of see here. So each one that has a J, you know, it will be substituted by the like each row is a different card value to substitute, and then each column will be the hand values. And we can just calculate the hand strength for each one, and then we can just find the maximum value for each column. And that's basically the strongest hand that each one could represent.
Yeah,
yep.
That's a fun way to do it.
That is one way to do it, yeah. And then we just, for part two, because the ranking is slightly different, we basically like remove J, and we just make it the least valuable card. And we use our same score calculation for part two. So
yeah, I think I did the replacement. Oh, sorry.
Oh, that's
someone else speak
for day 7.
Yeah, I think I got off of the Reddit that you replace the jacks, the jokers for part 2 with whatever the highest occurring card was. But I didn't do it this fun way with the outer product. I think I used a key and then did some really awkward defun to grab stuff out.
Yeah, so, I use the same technique. Not the outer product. I just use the most numerous card for the joker, and you just put that in.
Yeah.
Yeah, so I think. Oh, real quick, Rich. I think you commented on my video or something, and you pointed this out. And I think that there's like an edge case for 5 of a kind where you have like 5 jokers, and I think some people, at least on Reddit, ran into.
I had to put
like the most numerous group.
I had to put a guard for that in mine. Wasn't nice. So Jay,
I was just going to say that there's a bit of a logical leap there, because if you just read the description, if you've got 3 jokers in your hand, you are allowed to replace them with 3 different cards. So you kind of have to see through that and realize that is never going to get you a better hand than you could get by replacing all 3 of them with the same card.
Yes, that is true.
I'm just checking the comments to see what's being said about 5 of a kind here. What's the name of that game? Pinocchio?
Oh, Pinocchio.
Pinocchio.
Yeah, it's a great game.
Oh, yeah? You have to teach me.
But yeah, I can. So that's day 7. If we don't have much to say about it, then I can move on to day 9 and do that real quick, and then we can get to the heavier stuff.
No, what's the suggestion here? Since none of the numbers go above 13 and it's only 6 columns, could have used encode to collapse it all into one.
Yeah, that's what I did. That helped with scoring. So instead of sorting the table, a 2-dimensional table, I compressed it all into one number, moving encoding everything obviously into 2 digits, and then into 2 numbers, and then moving the rank or the number of repeats or whatever it is by multiplying it by a big number to move it just a little higher in the sorting algorithm.
No, neat. Very cool there. Sorry, Isaac, you explained a fairly good plan, and then I got distracted by the comments. But
yeah, no worries. Should I move on to day 9 then? Or
yeah, go for it. Yeah.
Cool. All right. Let's see.
I was considering skipping it, but I think that was actually a fairly straightforwardly understood problem. The card sorting one.
Yeah. Okay. So day 9. Again, a lot of flavor text, but basically you are getting these groups of lines of numbers. And the idea is that for each line, you kind of do this, let's call it interpolation, where I think you're taking the sort of pairwise difference of each one, and you're constructing these rows, and you basically keep doing that until you get a row of all zeros. And then we have to, the idea is that we're adding one more kind of last column here. And the last column, I believe, can just be calculated by basically doing a plus reduce or a sum on the last column here. So like this value's 18, and that's 3 plus 15, right? And so we do that for, yeah, so the 28 up here is 21 plus 6 plus 1. And we do that for each one of the numbers, and we add them all together. And then for part 2, it's basically the same thing, except we're prepending a column. And depending on how you do this, you can basically just kind of reverse, and the same algorithm applies, right? So I think just a lot of people found this day pretty easy. The algorithm is, you basically do this interpolation, you're generating these rows, and then you just do a plus reduce on the last column. But Rory Kemp in the Discord pointed out that you can do something kind of different and a little bit mathy. I'll try and breeze through this somewhat, but I thought it was a really cool solution. So it turns out that what you're doing here, and I'm not really that great at math, but it seems that you're doing polynomial interpolation. So the idea is that these numbers represent coefficients in a polynomial, and then the idea is that you're trying to predict what the next point would be. And you can do you could do polynomial interpolation using this thing called a Vandermonde matrix.
Go on.
Which, you know, I always wish that I knew more linear algebra, but this is apparently a cool tool that you can use to do that. And this allows us to make use of the matrix inverse, which prior to this year I've never been able to use, but I always wanted to, and I think you can use it like 3 times in this year. So
right.
Yeah.
Oh, this is brilliant. All right, you're gonna have to take this. I'll slow you down at points. So you can take us through this, and I'll try and help us grok it.
Sounds good. Okay. So first of all, I
know for sure I would have done something iterative on that, and I saw Aaron's code, and it's, to be fair, like the part 2 to part 1 thing is a pretty clean transition. I think Aaron's second part is literally just getting rid of a couple of reverses or something, like you sort of described at the beginning. Like if you just read through the description and the algorithm, that's the way you're inclined to do it. But I'm very intrigued now.
Cool. Yeah, I'll kind of breeze through this, and then I think maybe people can do, you know, self-study if they're interested in more. But basically, we're you know, we parse we parse all the numbers into a matrix where each column represents a particular line from our inputs, and then R is just the length of that. And then we have a function where the Vandermonde matrix is, you can generate this with like an outer product, but basically it's like
just like a times table for geometry
with exponentiation table is basically what it is.
Yeah, okay.
So you know, we look at so we're generating like a,
if I read the code, it would have been obvious.
You take the inverse of that, and then you can do like an inner product to apply it to you know, each one of the rows here. And yeah, the idea here when you're doing interpolation is you can take the inverse and you like multiply by your coefficients. Anyhow,
this is one of those times where like the Haskell community would be proud of us. Like we've taken a basic iterative operation and we've just buried it in math.
Yes. Well, this is like one of the things that I think is super. So, are you guys ever heard of those like iceberg videos where you take a topic and you sort of like get slowly more obscure? So I feel like when you're learning APL, it's like at the top, it's like, what are those weird glyphs? And then as you start getting down, you're like, it's all linear algebra. Yeah. So like as I get more proficient with APL, yeah,
I haven't heard the words like eigenvector yet.
Yeah, that's right.
The one edge of the iceberg cliff goes off into combinator land.
Yeah, exactly.
The other side's all linear algebra.
But this is actually a really nice, clean expression. I really like that.
Oh yeah.
Yes. Yeah, it works out pretty well. The problem is that you get an overflow if you try and take the inverse. So you got to do that. What is it? 128.7 to get 128-bit floats.
Yep.
Okay. Now it works. And then so that's part 1. And then for part 2, you literally just have to reverse the matrix along the sort of major axis there. So that's like an overview. I probably did a bad job explaining it, but this is the great idea.
I think 128.7 is going to come up again if I have a chance to talk about it. So I think we should hone in and say this is like a really fun competitive advantage in a lot of this stuff, where we don't have to work around the fact that most of the time people are working in 64-bit floats. Like at some point, sometimes we can really cheat and brute force and just say, oh, we've got rounding errors. Never mind. Let's just throw more bits at it. It's remarkably useful sometimes in some of these things.
Don't worry, Isaac. You've had the highest praise in the comments there.
Oh, okay, great.
Quote. This is actually quite entertaining, which I'd say for like internet content is pretty up there.
So Isaac, I'm curious, what happens if you take the final ceiling out of your f function?
Oh yeah, well, floating point errors, right? So so if you do this for like part 1, oh, that actually works.
Shock.
I know. So I know if you do these like one at a time, basically you'll get something that's like close to epsilon away from your answer. And so actually ceiling doesn't work all the time. I should be doing like 0.5 plus and then like floor or something like that. But the idea is basically when so you're not getting an exact answer. It's you get some floating point errors there. Yeah, that's day 9.
Oh, awesome.
I wanted to maybe
Very
jump
cool.
in. I know that this is the matrix divide is a quite complicated thing, and maybe if anyone is feeling like they couldn't have been able to make it, I want to just say that the basic solution is also quite simple. Also is very good example of APL, because you just have the basic recursion function relying on a 2-pair subtraction. So it's pretty straightforward. It runs quickly enough, 100 milliseconds, good enough for me.
That's very neat. It's actually made me intrigued how long the matrix divide one actually is. But let's not go down the speed test rabbit hole. Oh, thanks for that. Next victim. Who volunteered because he found this problem quite interesting. That's right. Day 10.
No, I can do that.
Yeah. So, Stefan, if you're able to share your screen and then maybe talk us through the basics of what the problem is, and then I don't know whether there's like a naive solution and then what you discovered.
Yeah, well, I can't see if it.
Can you full screen or?
Can you see my screen?
Yeah, the text is a little on the small side. We can see your whole screen just so you know. Is
that better?
Can you zoom in a couple?
Bit more.
Bit more. A little bit more.
Like that. Is that better?
Yeah, that'll do. Yeah, that's good.
Yeah. So I mean, this is another kind of staple advent of code kind of thing. The path finding in a sort of massive ASCII matrix maze kind of thing. Yeah. So we have a set of pipes, and I think that there are a couple of complications here. One is that the corner pieces are Fs and 7s and Ls and Js, and it's kind of well, it took me a while to map that to my brain. So that's one complication. Another complication is that there's also a lot of junk in the matrix. Yeah, so it's kind of obfuscated by that the floor pieces can have any sort of character in there. So you just have to sort of keep track of the exact how you sort of follow the path, right? And sort of it's a sort of there's nothing magic to part 1. It's a matter of you find the start point and then you kind of carry on sort of walking this path, making a note of your path, and the aim is to sort of figure out how far is the furthest point, how many steps in that, and I just wrote this in a.
Hey, can you scroll in, zoom in?
Yeah, in a fairly naive kind of way. It's a like you would write it in that. This is just fun to do sort of a recursive leap. Yeah, that I think isn't the interesting bit of this problem. The problem comes, and the interesting bit comes in part 2, where basically what we have to do is if I scroll back to part 2 here, is to count the number of enclosed points in this loop, right? So in this case here, the enclosed points we're looking for would be 4 of them, would be those 2 there, and then there'd be those 2 there. And what makes it hard is that the path can sort of be adjacent to itself with no sort of floor tiles in between it. Yeah. So and actually you can have things that are, you know, enclosed in this sort of way as well. That you have these 2 internal points here, but these ones that are sort of zeros here, or O's, capital O's, they are sort of outside this path, but you can't sort of get to it, right? Because the sort of little corridor in here has no sort of floor. So it's like the 2 walls are touching each other. So our task is to count the number of properly enclosed
right. So in this
tiles, not like this. So in this case, it would just be those 4 points.
So you have this
right?
loop that's following the F's, J's, L's, and the straight pieces. And yeah, okay. If you stare at it long enough, you can see that the I's are enclosed, the O's are actually outside of the loop.
So this is similar to problems that have been in the competition before, and the way that certainly I've solved before will be with a sort of flood fill algorithm. Yeah, that you sort of, you know, you look at all the neighbors of a particular point, and then if they're sort of floor tiles, you sort of, but you can't quite do it here. And if you want to do like a flood fill, what you have to do is you have to stretch it, you know, and sort of, and where you can imagine like injecting something between each sort of point in both sort of dimensions, which isn't a dot, and then you do a flood fill, because now you can sort of get anywhere, and then you need to sort of subtract your extra fill kind of thing. And I started thinking along those lines, and then I thought, no, my life is too short for that kind of thing. But then someone pointed out, and I can't take the credit for having discovered this, I think it was Nicola, saying that there's actually some clever maths that you can apply to this.
I'm sure this was posted on the Reddit as well.
Yeah, there are formulae for calculating these enclosed bits of a polygon described by its vertices, right? And so if you know the area, and then you know that the sort of essentially the circumference of one of these things, yeah, you can calculate it, and it will take into account the cases where these things are the walls are touching. Yeah, and the first thing you need is this thing called the shoelace formula, which is a way of calculating the area of a polygon given a sort of list of its vertices. Yeah, and as I say, like it's pretty easy to implement. So it's actually very, very simple. But I've heard of this before. This is sort of cropped up before in this competition. Yeah, but
I think we did it in the APL problem solving competition one, a phase one. I'm pretty sure, or phase two, I can't remember. It was somewhere in there.
But I think the interesting thing here, and this is what someone sort of discovered, not me, but that there's also this thing called Pick's theorem, which is a way of saying, you know, given the area, if you know the area and you have the vertices of a polygon that fall on a grid, there's a formula for calculating the enclosed points. Yeah? And it's actually very simple formula. It starts off with you know, if you know the area, and then know the area is equal to the internal points boundary over 2 minus 1, and so you can just rejig that, and out pops a number, right? And actually, I just implemented the shoelace formula, and this sort of Pick's theorem. It actually becomes a little bit simpler, even if you because each of the vertices will only be like one step apart. Yeah, so actually the formula becomes even a little bit simpler, and sort of out pops the number, and obviously it's super fast. Yeah, and it's whereas I imagine like doing the flood fill proper would be a reasonably costly sort of operation to solve it that way. So yeah, and I think again,
you still have the fiddle around to find? You said there's a bunch of junk in the map, and there's the pipe. And presumably your formula there is only caring about your pipe.
Yeah, that's right.
vertices.
So I assume that when I got to that point, I have a description of the actual path. Yeah, and the way that you calculate. I mean, I'm sure that there is more elegant ways of following the path, but I just did it in the most sort of simplistic way. I just go 1 point at a time, look at the neighbors to see which ones are the valid points, and whether just sort of trace it through. So yeah, that was it. I thought it was a very interesting problem, and I think it's another sort of thing that occasionally crop up in these things that you can usually tell if something starts taking a long time to run. I think he said, Eric, the creator of this, that no problem should take more than 10 seconds to run on a 10-year-old machine, and if you start taking there, then you're probably barking up the wrong tree. So it was quite a fun problem, I thought.
Well, there's
it's
a bit
interesting to see this.
A bit of a
I did the flood fill approach. So.
Oh yeah, do you want to show how you did it? Because did you go about the stretching, or how did you do it? Or
yeah, I stretched it.
Yeah.
Wonder if I can get.
In your code there, Stefan, your variable path, what is that? Is that like a vector of coordinates or something?
Yeah, exactly. That's basically what pops out of my step one. Is basically just a set of vertices. Yeah, as
okay.
Tuples. Right.
Because the first thing, I have not solved this problem, but the first thing that sprang into my mind is if you have a matrix with ones in it for everything that is on the path, then it's pretty trivial, I think, just to go row by row and do
like a scan.
plus scan. Well, is it an X-score scan or something? A 2 residue of the plus scan to tell you, to give you like an alternating value every time you hit a pipe edge. And then only count the interior points where you've seen an odd number of pipe pieces. So there's no kind of flood fill involved. That should just give it to you.
That's like applying the principle of the shoelace formula.
Okay.
Mechanically.
There's an issue with that one. If you have it's like, let's say that you had like a line of horizontal pipes. So you have like an upper corner and then a horizontal one and then like another bend. You have 3 pipes there. And so like just like doing the plus scan and then determining whether it's like even or odd doesn't work, because you may have like multiple pipes in, like if you had like a little down jut and you had 3, it would count everything to the right as being like within when it's not. So there's some additional logic on counting corners and things like that.
Right. Or you could. Yeah. Okay. No.
So Jay's approach is the one I took and it worked. However, then I tried to do the same thing, but instead of doing it row-wise, do it column-wise, but obviously flipping the corner pieces, and that didn't work. So that tells me that there's either I made a mistake somewhere, or it doesn't actually work, like Isaac mentioned, in all cases.
Yeah, I think you have to account, like there's the flipping that occurs, there's the way you count it, at least in the proof of the shoelace formula, you have to like have one direction and another direction that cancels each other out as you go through, and it will let you count and then sort of like take away bad things that you counted too much of or something like that. I haven't actually thought through what you have to do, but I think that's at the root of the problem with that. I gave up on that approach because I couldn't think of it. I couldn't like rationalize it in my head how to actually think about all those edge cases.
So a couple of bits from the chat. Brian confirms that we did shoelace formula problem in the APL problem solving competition. Francesco also asked, I see Stefan's replied, but just for the VOD, someone's asking is if Stefan, oh no, Francisco's asking, is Stefan's notebook that he just showed with the shoelace formula is available? Stefan says he'll make that public at some point after this, and I guess we'll try to put links in the description for whatever we've got. At this point, I wanted to I'm going to suggest a couple of deviations before we go into other problems, or maybe take a break and then do other problems. And one of those is in the chat. Now I can't remember who asked this, but someone was asking about, because in the day 3, when we looked at stencil, and Aaron made a sort of throwaway comment that he uses the stencil function. It's just the special
seed of dissent.
the special cased. So stencil is this operator. Very briefly, it gives you these sorts of sliding windows around a multi-dimensional array. It's used in image processing, neural networks, and all kinds of other, and advent of code problems. And in APL, it's an operator, so it takes an operand function that then applies to the contents of these windows. But instead, and some of those expressions that you can use, or some functions, I think they're all dfns, aren't they? Dfn expressions you can give as operands to stencil are special cased, so that they are a bit faster than if the interpreter had to go and do. Now, I'm not establishing the exact reasons. I'm sort of setting a little bit of the scene. So what Aaron uses is just open curly brace, omega, close curly brace, stencil. Or sometimes you use right tack jot enclose, or enclose a top right tack to get the, you're generally doing it. You're muted, by the way, but you're generally doing the
yeah,
flaps.
I generally just do that. Especially if I'm trying to write clean code, that's what I'll do.
Yeah.
You could just use a right tack instead of the omega and braces, but whatever. Yeah,
so Rodrigo piped up in the comments about you. So you worked with him on a paper doing this is the UNet CNN convolutional neural network paper. And apparently at one point in the drafts, there was a section you had about issues with stencil as an operator versus as a function. And then he says that you might have had to cut that section out in the final version that you submitted, etc. So that person is asking, I just wanted to pose it to you. Do you have any comments on your use of that?
Yeah, the logic for that is in the paper that I linked. I linked the paper that includes the analysis for it. That our ICFP draft submission had the analysis of the stencil operator in it, and we dropped that for our array 2023 submission that got published. So the published version of it you won't see, but the draft submission for the year before that, you can find that in there. And so I linked that in the repo, and there's a PDF there that you can see the arguments.
Okay, so the main issue is not simply one of like performance in particular cases, but also ergonomics of using it as well.
It's largely a matter of the fact that the composability of the stencil operator is poor relative to the rest of the language. Whereas if there's a stencil function, which is the stencil operator given the identity function, if you use that instead, you get a more composable compositional operation that jives better with a lot of other APL primitives and can communicate a little bit more clearly in a lot of cases. You don't lose any actual expressive power, and then you don't have to maintain a combinatorial explosion of special cases for all the code to get high performance. Because in a lot of cases, like what we ran into with the UNet paper, was that the special cases couldn't cover the kinds of code that we needed to write. And the chances of encountering that a lot are very high,
right.
Especially as you want to use it more and more and do more things with it. The ability to write or to take advantage of other features in the language or other implementation features inside the runtime are lower.
Because this sort of smells to me of like this whole when you try to describe what the sort of APL-ish approach to things are, a lot of the time it's using a small number of primitives to do a transformation across a whole bunch of data, rather than writing some whole bespoke function and then doing some iterative or recursive
I mean,
approach.
basically it's just that the at all levels the stencil function is more compositional than the stencil operator.
Cool.
As an idea.
That's actually super interesting. And what you mentioned before in terms of performance is super counterintuitive to me, because to me is always, my thinking is I gotta do as much as I can inside that little function, working on that window, so that it doesn't just return all that data that I'm gonna throw out a second later. But it sounds like it's the other way around.
Yeah, we tried benchmarking both approaches, and even with what special cases we could get out of the stencil operator, it was not nearly as fast. And part of that is because we couldn't take advantage of, for instance, highly tuned matrix multiplication in the case, you know, in a higher dimensionality than rank 2. So above matrices, you weren't getting the performance that you needed out of the stencil operator for high dimensional matrix multiplication. Whereas if you use the stencil function version, you got the performance of the built-in plus dot times performance.
May I ask then, when you return stencil, just have a omega return whatever it is in stencil operator, and you have a 3x3 window, does it mean that does it actually create a 9 times more bigger matrix in the
yeah? So currently it does materialize most of that data in the interpreter runtime. But for instance, in the Co-dfns runtime, we have the ability to not generate all of that data for a lot of cases. We might still have to materialize it, but we don't have to materialize it in certain cases. And that's where the compositionality comes in, is we don't have to make decisions about the laziness of that materialization upfront just for the stencil operator. We can sort of make it part of a generalized lazy computation framework in the runtime itself. And the Dyalog runtime doesn't do that right now. So you can still get advantages with using the stencil operator. If you have those special cases, you might still get memory usage advantages and performance advantages doing that. But in general, if we were to optimize, we would be able to optimize more cases by using the stencil function and optimizing for reducing our memory materialization, or reducing the amount of memory that amount of data that we materialize, and composing those in better ways than special casing the stencil operator itself.
Interesting. It still sounds a little bit like what you're saying is, and I know it's probably not correct, but that we can't optimize the stencil operator window because of too many edge cases. So instead, we return more data and optimize it later. But
well,
then,
yeah, no. So what I'm saying is that from an engineering architecture point of view, the optimizations can be decoupled from the operator. So if you, for instance, have a way in your runtime to do lazy indexing of any sort, right? You've got some kind of lazy indexing where you don't have to materialize the entire indexed array. Stencil can take advantage of that and then feed into any other function that knows how to handle lazy functions. And then all of those combinations you get for free as special cases. Whereas if you had to do that same amount of optimization with just the stencil operator, you'd have, you know, n times n different combinations of functions that you can't optimized very well. Like for instance, the curly brace with the omega in between, that's special cased in the Dyalog interpreter, but the equivalent train or tacit version of that is not optimized, last I checked. And so even though they're semantically equivalent, one will cost you much more than the other potentially. And so that's where the benefit is. You can still sort of technically try to do it, and it's within reach, but it's just combinatorially more work to handle the same amount of cases one way versus the other.
Yeah, no, that makes sense then. So instead of optimizing a particular one operator, you can optimize the whole pipeline,
right,
using the same amount of work, and you get more benefits in the end.
Right, exactly. Yeah. Although I don't know how much everybody cares about these kinds of like low-level APL implementation details.
No, this actually bit me in the later days because I had the code and where it was using stencil, and I put a lot of code logic into the window operator function, and it was slow. And I look at your solution, and it's same solution, but runs in milliseconds, and then I had to find where the difference was. Obviously, they're not exact same code, and it was just that. It was exactly that.
Yeah.
But maybe we'll come back to that if we get to one of those later problems in a bit. The only other non-looking at solutions deviation I wanted to raise, and we can skip it if people aren't particularly interested. But I saw on your repo, Peter, that you have like a Sublime Text set up for doing APL, and I know that this is something that's sort of cropped up in a lot of discussions that I've had with various different people in various different places over the last, I don't know, year and a half to 3 to probably the whole time I've been at Dyalog. But is this question of like workflows and working with APL and the different ways that people do it? Because if you go through any of our sort of introductory things, a lot of them tend to give you a very traditional approach of like they're teaching you how to use the Dyalog IDE interface alongside teaching you the basics of APL and stuff. But then a lot of people are coming from other, they have experience with other programming languages already, other paradigms, or they're just, these days very used to the idea of you write a single text file and then you execute that like a script or whatever. So having seen that, I was just sort of intrigued about how it works. I'm guessing it's quite straightforward. It's just Dyalog script, is it?
Exactly. I can share real quick.
And I think Isaac, were you using Dyalog's?
It's literally
Dyalog
script,
files.
yeah.
We'll come back to you, Isaac. Sorry.
Yeah, it's using Dyalog script. I believe maybe it's the older version or whatnot, but I had to explicitly mention the configuration file. But that could be me doing something wrong. And it's just a Sublime thing that just pipes that file into the Dyalog script and returns the result to me. Well, that's a big result, but and that's usually how I start. I copy in defines functions, all of them, binary search, all the awesome defines functions that I might use, and then just start printing and start adding things. The only downside with this approach is specifically with Dyalog script maybe is that I have to explicitly print things, whereas with REPL approach you get the result out. But the benefits is that I have the whole history. I used to do the REPL approach as well, but the pain is that once I have the solution and then to assemble back like what was the code that I had, I have to scroll back or go through the history. Whereas here, as I change or undo, it's a matter of just Command B, run, and you get the output.
Now, shame I don't have RIDE installed on this machine. Something I do sometimes, although I forget to do it a lot. And Adam wrote a whole blog post about this. So what are they called? PF keys. There's a way that you can sort of assign either function keys, your F keys, or in RIDE you can do it to like pretty arbitrary keyboard shortcuts. And one of the options in the Dyalog IDE is called val, V-A-L. And one thing that's quite nice to do in the REPL sometimes, although I can obviously see the advantage of this. I'm only mentioning it in case people don't know about this. But you can have your function tracer / editor open, or you've sort of created a stub of a def or of a function, and then you give it your like example arguments. So Control Enter to trace into that, and then Shift Enter to enter the edit mode, and then you can write out your line in the editor part, and then highlight that, and then press the shortcut, and it executes that in the session. So then it stays part of a sort of function that you keep. And maybe if you want to save it, if you're connected using, or if you're using link to write out to text files, then you just press escape in it and it saves your changes more or less. Yeah, I just wanted to mention that. So I've got like Control Enter, I think is the shortcut I like to use for that.
But by the way,
This
I
is-
think
this is-
try make an experiment. If you put into that dialog script file, if you write 1010 ibeam2, then I think it will print out things.
In this one?
No, like inside your actual code.
Okay.
If you're at the top of the file, you can write, or wherever you want, write 1010 ibeam2. 1010 is, I mean, 1010, sorry.
Find ibeam 2, like this?
Remove
No,
the space.
1010,
There we
sorry.
go.
Yeah. I wonder, now if you remove the quad gets, it doesn't do that. I thought it would do that.
I assume this is 18.2. I don't know if anything's changed, is it?
Yeah.
Yeah.
I thought it would print out the lines.
Jeremy's asking in the chat, Stefan, do you use the Jupyter Notebook as your main APL editor interface?
Well, that's a good question. I like notebooks because it allows you to do this sort of whatever Don Knuth called it, literate programming, right? But because I like to be able to intersperse sort of code and prose. Yeah, because I like to write explanations, verbose explanations, what the code does for myself. Yeah, if nothing else. Because I like to read the things I write, especially when you do things like this, yeah, where there's usually like clever quirks and stuff like that. That in 6 months' time we will have forgotten how they work. So I do like the notebook. I like the fact that, but you got to have discipline with a notebook because obviously you're not guaranteed the sequence when you start jumping around. Yeah. So if you depend on things that came before, you just need to make sure that you execute them in the right order. So I when I write things that will be published as I don't know as articles or blog posts or whatever, I like writing those in a notebook. But if I'm writing code, that's going to take more than like half a dozen lines or so. I sort of drift into the more traditional way of writing code in Ride because I use a Mac, so I don't have access to the Windows IDE. But I am, I guess, a little bit of an irritant inside Dyalog because I do think that we need to get better at working like Peter just showed, like inside other editors, and we should really allow people to use whatever tools they want to use to execute Dyalog. And I think one thing that would make this easier if what Dyalog would be able to if Dyalog script will be able to execute things off a string, right? Rather than having to be said like Peter showed, like having to first be written out to like a temporary file and then executed. Yeah. But if you could just give it a string and execute it, a lot of these things would be easier, for example.
Jeremy says he likes that. He uses Obsidian as a notebook, but Jupyter seems tempting. But I use Obsidian for brain dumping and other stuff, and I really like it. And I'm pretty sure you can write plugins somehow or another. I've seen people try to make executable code blocks within Obsidian. So now I'm tempted.
Try and write a plugin for Dyalog. That'd be cool.
Yeah, a little Obsidian Dialog plugin, that could be fun. And then, yeah, lastly, I guess we're going to bring up Isaac, you're a proponent. Well, I see you using .dialog files a lot, but I'm intrigued as to how exactly you. Because that's the I guess now old school text Dyalog APL format as things have gone over to Link or this Dyalog script. So you're somewhere in between.
Sure. So I pretty much exclusively solve these problems using rides and like at the REPL. And then basically once I've solved the problem, I do like a scavenger hunt scrolling back through my buffer and I just paste lines into a .dialog file. That's
exactly what Peter was describing. Okay,
so that dialog file is not some kind of format. It's just a dump. I call those files .apl because they contain the APL, but they're not. You can't really run them.
Well, the intriguing one that came up is Jesus been working on some science code, and he's got a .apls, But then in his README, it's also got, oh, if you're using the REPL, use this function, which is does a quad n get to get the text, removes anything that's not encapsulated in a colon namespace or as a function definition. So wherever he's put, raw executed lines in that script, it like strips those and then does a 2-quad fix on it to get the names. I thought, this is curious. We're gonna have to.
That's kind of how the old Apple Web used to work.
Apple
Web, the literate programming system for APL back in the day.
Oh, right.
But it seems odd because if part of your whole there's a big difference between having a bunch of definitions and having a sequence of things happening. If you just take away all the things happening, things might break, right? It's not. This doesn't seem right. You can't just take out things.
Well, anyway, it's a state in flux.
But I mean, what we're really missing is the functionality of taking a script, right? A dialog script, type script.apls, if you want to call it that, and run that from inside APL code.
Partially some other things.
We've all got our pet complaint about how we need to load our code in, I think.
By the way, that 1010 iBeam, it apparently only works if you are running code that's inside functions. Then it would start printing things.
So you wrap everything in a run trad and then call it at the bottom or something. What's that? Init main or something? Int main is run.
I showed Connor Hextra wanted something where he could just like press a button and execute the code. And I gave him this idea that what was I doing? Right. If you create a namespace, like colon namespace, a scripted namespace, and keep it open in the editor, and then you assign a keyboard shortcut for saving it, which is the fx event or fix event, which is by default doesn't have a keyboard shortcut. This is of course silly because you want to save your things. Then if you just put code inside that colon namespace, so lines of code, things to happen, then every time you save it, you press that keyboard shortcut, it runs all those lines of code, including printing things. So you could actually have like an interactive looping thing. But
it doesn't quite work. I tried that, and there's a problem because quad LC and the quad NR don't work well in that condition. So some things that we use in that Brandon Wilson and I use don't work under that model. I tried it recently, and the SI information isn't available to do the right things for quad LC and quad NR, I think.
Yeah,
so looking at the source of the thing itself.
Yeah, because it hasn't really been established yet, so it's kind of in the process of things. Yeah, it is. It's definitely a hack, but it works for simple things. But of course, what really makes sense is you should be able to run scripts from inside APL. You should be able to have a script open in the editor and then run them while they're open in the editor. There should be a special shortcut for that.
Well,
all right, cool.
List for V20.
Yeah.
Thanks guys for indulging me on that. Those couple of deviations.
It wouldn't be a proper dialogue session without a couple of tangents.
No, I felt like it would spice things up a bit. Had a comment. Last comment says Adám woo. So that's someone cheering you on.
I suppose that was on the comment of we need a way to run scripts from inside APL.
I don't know what it's specifically referring to because it's very vague. But basically what I think we could do is have another, we'll do another 10 minutes break. So up till 22. And then internally we're going to discuss what we're going to do next. We're going to have a break on the live stream.
Yeah, now or in 10 minutes?
Like now for 10 minutes.
That's not until. Oh yeah, you showed this. I can't read.
It's it should be until 22 the hour.
Yeah,
right, anyway, that's for the people watching, right? I'm gonna BRB them, right? So I'm gonna smack the microphone first. All right, so yeah, see you in 10 minutes. Hello, welcome back again. We were talking about you behind your back while you were away, or we were away. So now we're going to do a big leap. I think I expect us to go into the later problems here. Aaron, what was a particularly difficult problem for you, or where did you find it most challenging?
So after day 20, which I basically solved manually, analytically, day 21, I completely fell off the wagon. So the end solution wasn't that difficult, but I could not solve it for anything. So I had to end up asking for a hint. I had to go look up the hint. So all these other problems, I was not looking or using any hints or help or anything. And then this one, I finally gave up and I had to look up something. And it turns out the reason I was having so much trouble is that I was trying to solve it generally. I was trying to solve the problem generally, and that was not the right way to solve this problem. So, so I don't know if you can pull it up, but if you look at the puzzle input, specifically pull up the puzzle input. So this one is really interesting because it's part 2 puzzle input. You have this. You start in the center of this.
So where are we at? 21.
21, yeah.
So yeah, so
you start in the center of this grid, and you step out, right? And so you're basically looking for all the points that you can reach, going up, down, left, or right, from the starting point in a given number of steps.
Oh, that's right. It describes this. So you start at S. Next step, you can go to a dot. You're blocked by the octothorpes, the hashes.
Yeah.
So in the first step, you can go to these 2 points. The next step after that, you can go to any of these.
The interesting thing to note here is how there's this alternating pattern that starts emerging, right? So like every step, the number of steps you can reach forms this like checkerboard pattern in this whole thing, right? So this is the first like cool thing about this whole problem, right?
Okay.
So if there were no blocks or no interruptions, it would just form this diamond-shaped checkerboard as it goes out, as you're looking for all the steps that you can reach.
I'm sort of squinting and twisting my head. Obviously, it gets harder as you get more points to imagine what you're describing, but I think
so
a vague idea.
If you go to the puzzle input, right? So basically, you can solve this as just a basic expansion of all the with a frontier, an expanding frontier of the leading edges, right? Counting out how many different spaces there are that you can reach, and you can account for that. And the part 2 is imagining this map on an infinitely repeating plane in all directions. Now the problem is I was trying to figure out, okay, if you go down to the end of problem 2, you can see how many steps they're asking for. I think it's like 26,365,000.
Oh, right. So it's one of these. Okay, at first you can kind of run through it. 64. Yeah, that's fine. And then part 2, they're like, oh, actually, big number.
26,501,365. And so that. The problem I was running into is I saw this diamond pattern emerging from this problem, and I knew that there was, I was looking for a general solution to how to compute the area in the presence of these blocks that were blocking the path as it grows. But the real issue is I had looked at the puzzle input, but I hadn't looked at it with the right lens. So if you go to the puzzle input, pull up the puzzle
that's the other thing. So part 1, you've got this one block, and the number of steps is within the bounds of this whole thing. And when you get to part 2, it says actually it's an infinitely tiled repeating pattern, and it's a bunch more steps. So the problem just explodes in that way. So if we look at the problem input, don't stare too hard because that's oops.
So pull up the puzzle input.
There we are.
Yeah. Now shrink the font size for this. This is the key here, right? This is what I wasn't doing initially. Yeah.
So like you can see the whole thing now.
Yeah, but what
You can see
I
the
didn't
diamond
realize,
pattern. Yeah.
and the moment that
Oh
somebody
my
said,
gosh.
look at this, it became obvious. It was just it's dirt
Oh,
simple
yeah.
once you do this, because not only is there this diamond pattern, which exactly sort of matches how the puzzle.
How much have we lost, Aaron?
At the start are
Okay, no, you're back.
yeah. If you look at the direct horizontal and vertical off of the start, it's completely unblocked.
Oh, the S going.
Yeah, if you go from the S left and right, it's completely unblocked.
Will it turn up? Did anyone see that? There it is.
Yeah.
All right.
Oh yeah, it goes all the way out.
So once you notice this, that means that you're guaranteed to be able to get to these edges in a certain way, and the diamond pattern is going to emerge correctly. And that extra space is this like buffer. So all you have to do is you just compute the area that you're consumed up to the edge of the first plane, and then do this once or twice more, out a few more times, and look at the quantities. And if you do that, a pattern emerges of an exact formula of exactly how the space expands. So my solution, if you actually look at my solution.
Hold on, I gotta get. Oh, sorry. Getting there. Input as a matrix.
No, you don't even have to do the input or anything like that, right? Don't even worry about that. Just look at the solution.
Oh, okay.
Yeah. So once you actually get the area, which is that lower paragraph, once you figure that area out, all you get is this like closed formula at the top.
Oh, I see. So here, this is your actual input.
Yeah, I just ran that on a few
steps.
steps out. Like I think the size is like 131. So I just took it like 131, a factor of that out of the steps. So it's 65 plus 131 plus 131. So I just stepped it out a few times and figured out the areas there, and then computed the differences. And I then fiddled around until I came up with the closed formula above. And that's the area. So once you actually saw the pattern in the puzzle input, it was dirt simple to do. But I could not see that pattern for whatever reason. I could not solve the problem because I was going down the wrong path, and my depth first search could not terminate. I couldn't prune it. So
yeah, that's pretty canny. There seems to be there are sort of deliberate things in the puzzle inputs. We've already talked about this in earlier problems where.
So if I would have paid attention to the puzzle input a little
case.
bit more, this would have been so much easier, and I might have actually not gone crazy. But
But what are the numbers this computes is
the number of
those
places
O's
that you can reach in a given number of steps.
Yeah. But you do that a couple of times going out.
Yeah, and that gives you enough to see the pattern. And that's all you had to do there. But so this one is really frustrating because it was so simple. And if I had only seen it, it would have been really easy. But I just hit a wall on this one. So I had to give up on that. Or give up. I had to go look for an answer.
Yeah.
So, yeah. Yeah.
Does anyone else have any comments on day 21? Or is it pretty much...
Did anyone manage to do something the same?
Did anyone manage to do the iteration?
I did the same. I did the iteration. I did conclude for me somehow. The only difference, it looks very similar to mine, albeit yours is much shorter somehow, even though you have two solutions separately. The only difference I have is that, so I mean, maybe this speaks to how traversals happen. One way to implement traversals, one is to use two-dimensional elements. You can also, like, I see directions being, -1, 0. So I'm guessing you're using two X and Y kind of coordinates to traverse.
Yep.
I used imaginary numbers. That's another one a lot in Advent of Code. It's annoying to work with them if you need to convert back and forth between X and Y, because you have to use the circle operator, then you have to multiply it back by 1 and 0j1, and they're also super slow compared to normal numbers, even if you have them separately. But they allow you to have, I don't know if it was useful in this one, but allow you to check for presence, right? If you have a coordinate that you maybe have seen already, you can just check if it's an array. Whereas with 2 coordinates, it's you can still do it, but it's trickier.
Yeah, so you'll notice in order for me to count the double step operations, I'm using this without on the current and the previous to achieve that checking for previously seen values.
Right.
Yep.
Okay, cool. That's pretty crazy. Get change your perspective.
Yeah.
And also,
then
just go ask.
I am also curious if anybody solved day 23, but
I did, but looking at the code, I can see that it's basically for loops just converted to APL.
Okay.
Without the for loops, it's just like for each, and inside is for each. It wasn't very doesn't look good, but I did end up simplifying, because you need to simplify the graph, at least for part 2. But then I believe, if I remember correctly, it was the one where you have to follow the hallways, right, and then find the longest path or whatever. Is that
yeah.
Okay. So you have to obviously short circuit a lot of those. If you're just going a straight line and there's no other way to go, you just teleport directly there.
Should we take a look?
Yep. Yeah, you should pull your solution up.
Or in the problem as well.
So that's 21, right?
23.
23. All right.
Before we jump into the next problem, I unfortunately have to leave all of you. But
yes.
It's been a pleasure. It's an honor to meet all of you finally. So, and thanks to our viewers as well.
Yeah.
Thanks, Isaac. I'm sorry you couldn't stick around for the tangent that you've suggested, but I promise we'll make some content, at least for your benefit, if you check back where we talk about the question that you raised earlier.
Very good. Yeah, carry the torch. Thanks, everyone.
Yeah.
Thanks, Isaac.
Thank you.
So it's actually quite simple. So you have this hallway system. You start in the beginning right here, and you end at the bottom right here. For part 1, you need to find the longest path, and you have to respect these arrows, meaning it's one-way street. Whereas in part 2, I believe they just get removed, and now you have a bit more explosion. Not that significant, but I guess significant enough to need to simplify the optimize the solution. And then the easiest way, and I think in terms of traversals of graphs and things like that in APL, what I find is the best way is if you can not think of any one individual coordinate, but work on the whole matrix as a whole. So that, for example, for breadth first search, right, you're not looking at I have these coordinate positions that I need to investigate. I just you work on the whole matrix with every iteration, as opposed to individual coordinates. I don't know if I explained it in a good way. Maybe the one example would be the Sudoku solver. The one on YouTube is a good example of just working on all solutions as you go down the tree. Here it doesn't work, obviously, because you're just one person, and you do get to choose some place, some places to go. So you do have to work on individual coordinates. So for part 2, when it gets more complicated, which I needed to do was simplify some of the shorter straight lines. For example, if you start here, there's nowhere really you can go, especially if you remove all the one-way signs, until here. And this is the really, just one jump. So the graph becomes much smaller, but there's more complexity. So if I present my solution, then I don't want to go into code too much, but I do have the simplify function, which takes a graph and returns one thing I should mention, if I remember correctly. I'm using the conventions in dfns namespace for representing graphs in terms of
so that's a vector
array.
of
exactly. So
nodes,
for,
right?
at position X, you can look up where you can go further. And essentially what simplify does, it converts it from unweighted graph to a weighted graph, because now you have it's a smaller graph, but it's one where you have weights now. So because to go from one place to another, it's actually multiple steps in the real map. So that's what the simplify does. You can see this is basically a for loop by for loop, and each. So not very pretty. I'm sure there's a better way to do this, but actually, no, Aaron, I think I've seen your solution do this in one line, the simplification, if I remember correctly.
No,
Okay,
the simplification of the graph, I think, is 2 lines.
Well, longer than whatever this is. And then the traversal is, you obviously have costs for, so I generalize it afterwards to support, to actually work in the both first part 1 and part 2. So obviously for the first part, the costs are just ones, so they're pretty straightforward. And then the traversal is just the usual run until you get nothing left over. Right, yeah, after the next, until the next point, next iteration is empty, then just stop. That's basically it.
How did yours terminate?
Let's see.
Mine didn't terminate.
It takes some time, but it did terminate, because that's how I know I got the answer. First one runs quickly, obviously. Second one, I think 10 seconds, something like that.
Really?
So.
I've got to look at your solution more closely and how you managed to get a termination. Like this one, if this is the one I'm thinking of, it never terminated. I just printed the current best guess that the system had as it was going through, and when it looked like it had reached good enough, I just used that number while it was still running.
You did cut compress the graph.
Yeah, I compressed the graph. Yeah. So
yes, yeah.
Huh.
Okay. It does. There you go. Only 49 seconds, but you know.
Bravo. All right, that's cool. All right.
Not bad.
Nice.
So it's a shame that he had to leave, but before we came back from the last break, Isaac was posing a question that thought it'd be useful to explore. You know, a lot of people are coming to advent of code from other programming languages, or maybe a more conventional computer science background, and finding that a lot of the tools, especially the types of data structures that might be built into other languages, or things that they've been taught to use to approach certain types of problems, there's not an obvious direct equivalent in APL, or it's not exposed in the same way. And so what are the types of things that people have had to work around? I mean, his statement was like hash maps or other data structures. I mean, maybe the obvious thing is some people make not associative arrays, but you just, you know, like these lookups, you just use somehow the shape to work around that, or it is literally a table with a column for looking up and a column for values. I don't know, does anyone have?
Yeah, well, we have one of the big things that I think people should definitely remember is that there are these idioms for doing fast catenation to arrays, and you have the ability to get hashing lookups in your finding primitives. Anything that might be based on index of, like interval index, index of, these other things, you get fast
I might actually share
table-driven lookups.
Let me find the Let's hope that Google does me good here.
Yeah.
So if we look at Dyalog hashed arrays.
Yeah, in my experience, most of the places where people benefit from these other types of data structures are usually in fast lookup operations for container. They want containers that give them fast lookup operations. I find it's much less common for people to need very, very, very fast update that has to be repeated over and over and over again, that can't be accommodated through an indexed structure and catenation, right? Most of the other cases, I've rarely seen needs for like tree-based containers that have like log and update costs and things like this for their stuff. They exist, but in general, it's not nearly as common. So like these all use tables or hashes or other sorts of fast auxiliary.
So I did Google search Dyalog hashed arrays and found this result on the page. This is the sort of restricting version, I guess you'd call it, where you define a function that is that right? Do you have to do the binding?
You don't have to do the binding.
It's just
the binding will preserve the hash table so that you don't have to recreate it all the time.
Yeah, otherwise, I mean, if you apply it with an each or something, then you want to bind it, then you can reuse it. Otherwise, it's only if you have a very large argument that you're looking for a lot of things, then it builds the hash table and then it uses it, then it discards it. There's also the I-beam to hash an array, where you mark the array as being
right. That's what I was thinking of.
Hashed array. Well,
So
you can go to APLcart and search for it.
Are both of these things expressed in this notebook, Stefan?
Yeah, exactly. I talk about those things on how to use a 1500 I-beam to hash, and I got at the bottom some speed comparisons as well. So I think this is probably pretty comprehensive for how to do some of these things.
But as far as a technique, if you're doing the basic stuff like working off of bulk sets of items instead of individual items at a time, and you're taking advantage of efficient catenation to your structures and other things, most of the time the combination of that with the hash tables will cover almost all your container needs. There are there's a couple of additional techniques that you can use, right? Like you can if you're dealing with the tree stuff, there's the my research on trees, but there's also you can do a garbage collection type of thing where you have a aliveness marker. So you can have a bit mask of things that are alive and not, and that allows you to efficiently traverse something without having to do a lot of array copying all the time. So you can control when you collect up and delete things out of an array.
Oh, so you're like marking them instead of actually acting on the array that they live in.
Right. You can mark them for deletion, and very often if you're dealing with sets of objects, you can encode efficient set operations using bit masks for certain things. If you want to do certain other, like if you're trying to do more efficient operations, you can simply use the bit mask or bit vector type encodings of sets and containers to get good results off of that. And another thing I think that people forget is that if you encode your data properly so that you're working primarily over small range integers, then the amount of copy overhead that you're incurring is really low, oftentimes. So even if you've got an algorithm that's doing a lot of copying in theory, if you're working only over small range integers, you might not have nearly as much memory bandwidth and memory pressure as you would expect if you're doing this off of another language where the container is technically more efficient from a computer science theory standpoint, but the memory throughput needs to achieve that are really high, relatively speaking, especially in terms of like random access memory, where you have a lot more memory fragmentation, and so your memory access patterns are going to be worse than a contiguous mem copy off of a small set of data.
So if you look at the beginning of that, it covers the the correct way, actually. Yeah.
I like it.
Right, that's in our Dyalog Jupyter notebooks, which I do have on the list to make a slightly nicer front for. But for now, we have to go through the GitHub interface. I don't know if it's worth reiterating again for the video the discussion that's happened in the comments about text idioms. Or I don't know whether it's actually quite a short discussion anyway. It's like if you put the go on.
Yes, the question was, you see a lot of not equal to enclosed right tag for split and stuff. Are there any other idioms that people use to sort of do a lot of parsing of input data, which is obviously a lot what advent of code is. So Adam mentioned a couple variations on the split thing there.
If you type text split.
Oh yeah.
Or text.
Yeah.
So yeah, I mean, usually or oftentimes the answer is to check APLcart.
And there's a few useful things in defense as well.
Yeah.
It used to be in the old days before nested arrays, so people would work with the segmented strings, they called them, abbreviated as SS. And there you have a special character, often like a slash or something, that separates the segments. So it's like a nested vector, a vector of character vectors. And then all kinds of operations to work on those.
Yeah, maybe one of the most useful idioms I'd say in that range is partition scan.
Yeah.
So being able, because there's no primitive in APL for a ragged scan operation over a vector, and so knowing the idiom for that is big.
Well, it isn't just one, right? If you want to perform it, you want this customized
I'm wondering if
scan for each one.
These
yeah,
depending on what you're trying to
scan.
do.
Yeah.
One rotate or reverse. It's one I quite like. They often involve scans.
Yeah, or the idioms for left scan or left associative scan is useful.
Oh, as in like left is no, I don't know. Is that in here?
Yeah. It should be in APLcart, yeah.
If it isn't, we can add it.
Yeah.
But this is it is like this, is it? Oh, yeah. Right, yeah, okay. Like the fold left, but with the intermediate values. Is that what you're referring to?
Yeah, that's one variation of it, yeah.
Okay.
That's also very useful.
It uses this technique that was mentioned in this group before the live stream started, of having a small defin that updates a semi-global.
Oh yeah, I sort of I think alluded to it on when we were talking about Aaron's day one.
Oh, something one of the things that you have in K, which is the scan, but for power. So you get like on the power operator, but you get all the intermediate values. I think would be a really nice thing to have. I know you can do it with
I think didn't Roger Hui have a proposal around that?
Well, there was a discussion about it, and that the power operator always returns you the last value and not the intermediary ones. And of course, there's an obvious extension is to just allow the power operator to take a non-scalar right operand. So you just write iota something, or it could even be multiple separate numbers, right? 3, 7, 10, and it would do all of them until 10, then select the right one. So it only do it once, right? As many times as necessary, right? But there are some issues, like often you want the fixed point, and then you want all the intermediary values, but you can't write iota match, right? It's not going to work.
Yeah.
Plus, I think even if that's added, implemented, there's always more that you want. It's I found that yes, you can implement it quite easily to just accumulate, right? It's not that complicated, but then once you have that, maybe there's something else. Maybe you want an intermediate value somewhere, or some specific iteration values, and not the actual result, but the computed value that I produce in the middle.
Yeah, so that it bumps into this problem similar to the string splitting thing, that there are many different variations. What exactly do you want to do with the separators, right? What kind of separators? Is it a set of different separators, or is it multi-character separators in the text? And each one requires a different type of splitting. And the same thing here with the power operator. Do you want the initial value included in the result, or you want to skip that? Do you want the final value? You want up until the final value? You only want the intermediary ones and not the final value? And all these things. What do you do if you're applying until some condition, but the condition is true from the very outset? How do you handle all these interesting situations? Not to mention running inverses if you have a negative number of. I think there's a flaw there in the design of the power operator already that can't really be fixed by extending it. But in that the J language, instead of using a function operand to determine when two consecutive iterations fulfill some condition, it just allows you to give it infinity, so like power infinity, and then it understands that you don't actually want to apply this function infinitely many times. You just want to do it until nothing more happens. And then you can use the power operator twice. So you have an inner power operator that is a function, takes a function operand that decides whether or not to apply, and then an outer one that's infinity. So the outer one just runs until nothing more changes, and the inner one kind of disables the actual action function once the condition holds. And so then that means the outer one will stop at that point. So you can use the power operator twice. That allows you to stop immediately before even applying once, because the inner power operator first applies its condition and says, oh, we need to apply this 0 times. And then the outer one that says infinity on it says, oh, well, nothing changed from the input to the first output. We're done. And now, since we're only using numbers to indicate how many times we want, then we can also get intermediary values by using iota. Although, of course, then we end up with an infinite array. We want iota infinity as the right operand. So there's still issues. But it could potentially be caught, right? You could not evaluate iota infinity, have it return some special thing that is picked up, whatever. Or you could live without the power operator, like people did in the old days, and just implement it yourself. It's not like it's impossible.
Yeah, because we still have branch and labels.
Okay, but you don't have to do it like that. No. It's not hard to like make a recursive defin or something that just iterates. Like tell recursive defin that just applies something onto the condition.
That's actually something I'm really kind of unhappy about my solutions this year for admin of code, is there's way too much recursion in my solutions.
Yeah, you did kind of say earlier that
I'm very displeased.
After about day 12, you struggled to sort of APL your way through it and had to go more.
Yeah, I started pulling out my computer science. I felt dirty.
Well, not every problem is such that APL is a good fit for it.
Bah, humbug. Blasphemy.
I think it's been fun though, Aaron, following your code, and it's not an 80 character long train. I can actually read it. It's been fun.
Oh, you like that, do you?
Hey, the recursive defense actually still kind of look nice, to look at. They just need some, a little bit of tuning here and there.
Oh, we want the T-shirt with the Aaron Sue Advent of Code one-liner edition. Right.
Cool.
There are exactly 25 lines
Is
of
that a
code on the
t-shirt or a
T-shirt. Yeah.
scarf? I don't.
That okay. Now you present me a challenge.
What do one line for every
Can I get
day?
this solution down to 1 line and 80 characters per line?
Oh, okay.
That's tough. I don't know if I can pull that one.
Too much
Anyways,
golf. Yeah, so I think, you know, we should maybe, you talk about struggling a little bit with some of the later problems. Maybe we'll go all the way to the end, and whether you and Peter between you want to decide how to divvy up 24 and 25.
okay.
Here's a fun fact. If you try to go to problem 26, it says that it hasn't been released yet. Please don't hammer this URL.
I also have a note here about day 17 that Peter said was particularly interesting, but we don't have to, we can see how far we get for 24, 25 and see how we feel after that.
24, I don't really want to talk about that one. Not very interesting in any way.
So I'm happy to talk about 24 because I spent enough time on it. If we want to.
To be fair, looking at your code's pretty, it's pretty intense looking.
Is it?
I don't know. I guess they just get
No.
point.
Okay, the code is not that bad.
Let's take a look. So let's first we'll do the description. I'll share my screen.
Yeah, so this one is really easy from a description standpoint. The first part of the problem is we have a bunch of lines, essentially. We have a set of coordinates, basically starting points and vectors from those starting points. And the first problem is to simply only consider the XY plane and look for intersections.
So what's the actual problem here?
You want to look for intersections in a region.
Right, because the description says something about you have these things and then they're traveling at some velocity described there.
Yeah, so you have a starting point and a velocity. So you basically have a description of lines. So I don't know if people are aware of this, but this is one of the standard ways of specifying lines in geometry. There are 3 standard methods for specifying lines in a 3-dimensional space, and this is one of them. I have now learned a lot about the basics of. Oh,
because it's like it's an intersection and a gradient. That's precisely what it is.
Basically,
no?
yeah.
Or a rather intersection with the whatever they call it, you know, the origin. Not origin, you know.
It's a
it's a point.
It's an origin
point on the line.
Direction, I would have said.
Yeah, fair enough.
Yeah. Well, it's a direction and magnitude of the direction. So there's a certain speed of the vector.
Oh, okay, right.
Yeah. So you know, so this is a standard representation for lines. And so the first part of the problem is just in 2D space, look for intersections within a given region.
Okay.
And so of course I had so all this is literally plugging in the formula for the intersection of a line segment. But there's floating point round off errors, so I had to go to the 128-bit floats.
Okay, yeah.
And so all this is doing is checking for whether it's in the region, whether it intersects at the wrong point in space, and all of that stuff. So that's pretty straightforward, right? You're doing the combination of all possible lines with each other. So that's what that final line is doing. It's just one of the combinations of lines, and you're testing each intersection to see whether they intersect, and you're reporting the counts of things. So that's not too interesting, right? But day 24 is in.
Oh, great point.
Oh, sorry?
You want part 2, right?
yeah, so part 2.
Yeah, I'm gonna have to use your code to get the
Oh.
the answer. What are we putting in? Matrix again.
Yeah, matrix.
Yeah, all right. What? Oops.
Is that a matrix? Not that one though.
Not that one.
Yeah.
This
one. Yeah, that one.
Okay. Oh, I shouldn't do that. I should have done shift. Doesn't matter. Okay. Without the last line, probably.
Yep.
Yeah, it doesn't die. Okay. Oh, nice.
It worked. Yay. Well, maybe.
Your
Okay,
answer is
great.
too low. Okay, no.
So all good. So then the second part is you now expand this to say there's a single line that intersects through all of the other lines in 3D space. And you need to figure out the origin of that line. And the restriction here is that they're integer vectors and integer position. It's an integer origin or integer starting point for this integer position and integer velocities. And so immediately I knew that we can collapse this down to like a single point, right? There's some, like, but I was thinking of it the wrong way, right? So if we imagine that line going through space, intersecting with all the other lines, I thought, well, if we project it and look at it from the top down, all of the lines intersect each other on the XY plane, right? If we readjust our coordinate plane. Now, problem is I had no idea how to do that. So, and I didn't understand, and this is the other problem. One of the 2 problems I had to go actually look up a hint for. And this was the other one. And the problem here is I then spent multiple days learning analytical geometry and projective spaces to try to find a solution to this problem. And apparently, from what I can read, you actually only need something like 4 lines to extract 2 potential related intersecting lines.
Yeah, you need 3, right? Because you have only 3 unknowns. I believe that's kind of the
well, you need at least 4 lines to anchor it. I think 3 lines will give you too many potential solutions in general, right? So in this case, this is like sort of a special case, but apparently what you have to do for that is you have to develop the reguli of a hyperboloid and look for intersections of the lines along the hyperboloid, which then exceeded my capacity for math. I just died at that point.
Can you tell me what to draw to visualize this?
No, there's a nice video.
Diagram?
If you do a Google search for how do I find the line intersecting 4 lines in 3-dimensional Euclidean space? You'll come upon
Give me a moment.
A discussion. Let me see if I can find it.
Intersection of 4 lines in 3D space.
Yeah, let me see if I can.
Intersection of 2 lines. 2 planes. There's a lot of videos teaching you how to find intersections.
Yeah, but it's not. Here we go. I think, is this the one? No, that's the easy one that didn't work for me. There's, I'll have to find the, and actually this stack exchange includes a comment from somebody saying that it helped them analytically solve Advent of Code day 2023 day 24. So it's possible to analytically solve this. We don't have to get into it. I think
yeah, that's
the
fine,
bottom line is I wrote pages and pages and pages and pages of equations trying to solve this. I used up I had to refill my fountain pen
the result
many times.
pages.
And what the real solution is, right? The thing that you can discover is that if you imagine all these vectors intersecting this line, if you rotate those vectors, they can all point to the same space, the same point in space, right? Which is the origin of that line. So you can shift all of the vectors by some amount to get to that space. And then if you look at the puzzle, or you can shift all of the vectors to point so that all of the lines will actually intersect at one point in space. And if you look at the puzzle input, the vector sizes are very, very small. And so you can simply do a brute force search through the space of the XY space, and then solve the Z space after the Z dimension after that to get your result. And so all I'm doing here is I'm iterating over the diagonalization of the rationals, right? I'm basically doing a counting of the rationals and counting up along the space, and then getting the so that loop, that bottom loop there, just starts at my like -1, and then the V successor function produces the next X and Y vector amount, and we shift all of our vectors by that amount, and then check for intersections. And because of my exhaustive research on this, I knew that the chance of lots of these intersections were going to be really low. So I can simply check for intersections up to a certain number and be very confident that I'll have an answer by that time. And so I implemented a short circuiting algorithm so that I didn't have to check all of them all the time. And then from there, I just used a basic basic intersection calculation. Yes, this is the shortcutting.
Yeah, space.
Yeah, so I just loop through the first few lines because I know once I've essentially seen 2 to 3 intersections that all line up, the chances of me having the whole thing intersecting correctly are really, really, really high. So
but it can be solved.
I can likely bail out really quickly on bad results, which lets me explore the search space a lot faster. And so this is just a brute force search through the space of possibilities in the XY plane. And then I compute the Z intersection and see if it's valid for any XY intersections that I find. And I also thought that I should be able to do this with matrix divide because this is a linear thing, but the formulas that I could come up with and the matrices that I could come up with were not valid. Like matrix inverse wouldn't accept them, even at FR 128.7. So I was producing the wrong equations to do this. And no matter what, I couldn't figure out how to get the equations right for whatever reason. So I eventually had to go do this. And it was deeply annoying because I wasn't eventually able to learn enough analytical geometry to solve this analytically, which was the path I was taking.
Yeah.
But I did learn that there's this thing called projective spaces, which makes all these equations really easy. I just didn't have enough mental power to learn how projective spaces work. So, but yeah, so
yeah, good
that was a very interesting. Yeah,
goes deep. I like when you get a
problem.
Well, I don't know. It's a lesson in the curse, and sometimes you get fixated on you're like, I know we can do it this way.
Yes.
It's just I can't do it this way.
Yep.
Yeah.
So.
Okay, cool.
But anyways, that was how we did it. So in the end, all you had to do was count up these vector shifts and check for intersections on the XY plane, just like you did in part 1, and then just extrapolate that.
I won't claim it exactly makes sense, but I'm sure it's a good enough jumping off point for people to go in and look further themselves.
Yeah. Well, like I said, this one was interesting to me because I had to give up on it. Well, I don't know that anyone else found it interesting.
Yeah, I didn't find it interesting. I did go the matrix. I saw it as a system of linear equations, and It was a matter of just building them, and that was the annoying part. That's the most, getting all those x, y, dx, dy, vx, vi. It was just messy. But I did end up using only 3 points. So I compare first with second and first with third, and that gave me enough of a matrix to do the usual ax plus ax equal b type divide, and then that worked.
I would love to see your setup at some point, because I couldn't figure out how I kept getting quadratic terms, and I couldn't eliminate the quadratic terms from the equations when I would set up those equivalencies. I don't know what I was doing wrong there.
Well, Peter's code is also on GitHub. There is a link in the description, I think, as we speak.
Does he have his derivations of the equations? Did you put those in there? Because
doubt.
Okay.
No,
I would really like to see those derivations.
It should be, if you're into the.
It should be easy. This is the problem. This should be straightforward. Everywhere it should be easy, and I couldn't solve it. I was very annoyed. My algebra is weak.
Yeah, I didn't like it because it wasn't very useful in terms of like solving it in APL. You know, like any other solution, any other language in COBOL, it will look the same. They just need to implement the matrix divide, inverse. Sorry.
Yeah.
Right,
I can see
try
that.
Building that up, right? Yeah,
I liked it precisely because it was sort of mathy.
Yeah, and there've been other ones we talked about today where the maths, the maths trick to the problem, as it were, is what ends up making it, at least somewhat pleasant to tackle. Otherwise, you're in.
Pleasant is relative.
Yeah. But Peter, you said you weren't that keen on 24. You preferred problem 25. So are you able to take us through that one, or we'll maybe finish off with this one?
All right. Let's see. What's my window? Give me 1 second.
And Peter, you said you used Carger's algorithm?
Yep. All right, so 25. Let's see, the input maybe. Right,
What is
so
this?
So you get, it's a graph from JQT. You can go to RHN.
Okay.
It's a bidirectional or non-directional rather a graph. You can go from anywhere to anywhere, and I believe the special component was something. Oh no, never mind. It was a matter of finding which 3 links you can break, so that you completely detach it, right? Completely separate it.
Something.
So that so the graph is strongly is fully connected right now, and there are 3 cuts you can make to produce two component groups, 2 connected components.
Right. So for example, HFX and PZL, if you cut them and 2 more, then you get completely 2 different graphs of size 9 and 6, and then you just multiply it and you get the result. And that was it, because there's no part 2. And then if I share the solution, I ended up just merging into 1 line. It's a long one, but I did make my font a little bit bigger. I mean, at the end, it's just a matter of grouping, keying, and then multiplying.
Let me move this.
Yeah.
And then the algorithm itself, you just keep using, at least the way I might have miscoded it incorrectly, because sometimes it takes 2 seconds or something. Sometimes it takes a minute. At least the way I've written it. But essentially what you do is, this is the inner loop right here. All it does is it chooses at random. Actually, there's multiple loops in here, because you keep needing to find breakages and merging points together. And I use the notation of V and E, which is common in graph theory, where you have edges and vertices. hopefully it's a little clearer. And so you randomly choose, well, you're supposed to choose one by one, I believe. But what I've done is I just randomize the edges that I will cut and start cutting them in order. I believe it's recursion, right? So I'm recursing on that. And then you just run it until you have a group, until you get to a point where you have two groups. And
Wait.
yeah.
So if you pre-compute the edges that you're going to cut, how do you count the merged edges for cuts?
So in some cases, it will do nothing, right, at each one of those operations, because some of those will already be merged and you don't need to merge anything. But all these, like, max and like just round to the next one, it eventually raises so the edges are just not, vertices are just numbers. So eventually it just gets to the two top ones that are not cut.
So you never cut the merged edges?
I do, but by that point they're basically a loop to itself, right? Because eventually you might have already merged it through other means, and then you just have a connection from one vertex to itself.
Yeah, but you never, so because you've selected the edges in advance, you never will merge a merged node. Okay, so for some people who aren't familiar with this, the idea behind the algorithm is that you randomly select an edge, and then you merge those two nodes that are connected by that edge into one node. And as you continue to do this, and you remove the self loops that are introduced by that merge, and then as you continue to do this, you will eventually end up with two components separated out by a certain number of edges that connect these two pieces. And so what I'm wondering about is that if you pre-select all your edges in a single random selection, do you ever have the opportunity to merge an edge that was created by the merging, right? Because you have to, once you merge two things, you have to reconnect the edges of the nodes that were merged into the new node.
Right. So to simplify it, an example, you have a triangle, right, where you have three vertices connected to each other, right? And then you take the top two and then you merge them. So now you still have those two edges to original two vertices that basically point to the same thing, and that ends up needing to be done twice, because that's essentially now the same vertex, same edge when you actually pre-compute it, right? So what I do is I choose the edge that I want. This is the first one because it keeps going through the list of pre-computed ones. Look it up and look up the edges that actually I'm using. So it's not the original two, but to the mapping of the merged ones. So that will already,
All right, cool.
And then yeah, and just a power operator. I think this is the fastest version I came up with. It's still slow because it takes sometimes longer than necessary, but yeah, I think it was nice and short.
Okay, I remember mine being really fast.
Well,
mine is not nearly as nice and concise as yours is.
How fast is fast? Like sometimes it's 2 seconds, sometimes it's 400 milliseconds.
Yeah, I don't remember it taking very long at all. I think that it seems about the same time. Yeah. You said yours sometimes takes minutes?
No, not minutes, but
okay.
tens of seconds.
Huh. Okay. No, yours looks like it's running pretty fast in general. So that seems fine, yeah. No, this is cool. I think personally, I think this problem and this solution is probably the most fun and the coolest problem in the whole advent of code this year.
There's no heuristic way of pre-selecting the edges in a way you're just sure it's going to be good. You have to just sort of.
There's a bunch of other algorithms that'll let you do this, but I think this one's particularly elegant because it's got a really high probability of success, and it's really simple to express, and it fits with the extra constraint of having just 3 cuts, right? The other ones, most of the other algorithms are looking for a min cut, and this algorithm can really easily extend so that you're not looking for a min cut, you're just looking for a 3 cut instead of like 1 cut or something like that. And I think it's yeah, I think it's just particularly elegant. I really like this.
There was so I ended up making it a bit more complicated. It's actually used to be shorter. I used 2 power operators in a train, another train. So there's a power inside a power. Instead of pre-computing it, once, I would just pick one and then just keep going until you run out. That was slower, but it was much simpler to understand and reason about, but it was significantly slower.
Yeah, I think that's what I did. Yeah. I used the 2 powers. Yes, yeah.
Oh, any more particular questions that anyone's burning to get through, or is anyone watching have any further questions for the people while we're gathered here today? It's a good opportunity to pick some brains.
I mean, if people still have the energy, I wouldn't mind seeing somebody's solution to 17. No, was it 17? No, not 17, 20. Yeah, 20. Did they solve it purely programmatically? Because I basically did that one by hand.
I didn't get that far, sorry. You're gonna have to ask Peter, I think.
I think so.
That was the one with the graph of it was basically the binary computer.
Right. It was still, it was a graph where you start at one point and eventually you get to the end.
Yeah, you kind of have to find the terminating what is it called?
Yeah, it's called pulse thing.
Yeah, it does little pulses, and you have to find how many times you have to push the button to get to the single pulse sent to the output node.
My solution looks long, so that suggests that it was not fun and cumbersome.
Okay.
I mean, the problem description was I only read a bunch of these so that I could have enough context for this,
right.
more or less. And this one was cumbersome to read.
So if you've ever done a computer architecture course, you would immediately recognize that all this is essentially like a logic circuit. Oh, wow. Yeah, so it was just a logic circuit with a set of computational registers, and you essentially had a bunch of accumulators that were counting up numbers to trigger a result. But I wrote the code to simulate the system and then just monitored the state of the memory of the machine and then figured out which bits were relevant to which things, and then rewrote the graph, reordered it, and like basically disassembled the code and put them into their own registers and figured out the dependencies, and then constructed the output that I would need to get the result and calculated it as a yeah, but I was hoping somebody had a less manual approach to the whole thing.
No, it doesn't sound like it.
Okay. Oh well, then that's the last one I had.
Yeah, I guess that
We can look at 19. I don't know how anyone solved it. I used a lot of evals there. Where I ended up.
Oh, 19 was cool. Yeah.
19 was fun, unless.
Yeah, no, go on. We got ostensibly 15 minutes, but.
Yeah, I wouldn't mind showing my solution to 19 either. That was I had a lot of fun with 19.
Let's do 19 and then we'll wrap up.
All right.
Right. Yeah. So you have these rules essentially. So if you get to PX, you start with in, I believe. And if you, it's basically if else kind of conditions line, where if S, you have 4 variables, XMAS stands for Xmas. And as you traverse, you check if it's less than, for example, 1351, then you go to PX, otherwise QQZ. And then you keep going. So if it's PX, then you check more, and eventually you end up with either A for accept or R for reject. And for the part 1, at least, you get a few inputs, just the 5. Well, in the example input, but for each one you get 4 variables for XMAS, and you need to check if it's true or false. And I'm guessing, yeah, you have to count. Yeah, adding up all the ratings, you multiply them by something. Doesn't really matter. The resulting number doesn't really matter, but it's how you solve it. For part 2, it's essentially the same, except, forget all of these points. They don't matter anymore. Give me all number of points that will work for these conditions, and you have the bounds of from anywhere from, for each of those variables, from 1, I believe, to 4,000. And you have to figure out how many. Obviously, there's going to be a lot. And you need to figure out how many of all the possible combination of XMAS that you can get working. Seeing this looked like APL to me, more or less. So
I think I did see someone say that they'd translated them to defns and then used execute. Was that?
That's what I did. Yeah.
That's literally what I did. So, for example, if what I did was just to clarify what each one means. So open bracket becomes setup, where you get 4 variables and it's a defun essentially. And everything else is already correctly done because 19E. So essentially what we do is to take the first one, we just extract, at least the way I did it, the 4 variables from W, and add. And then just keep. This is already basically APL, right? So you just replace the commas with diamond. You're done, and just add a leading last W. So that's what I did. It converts for the first one to just that, runs each one, converting from source to destination, and adds it up. For part 2, I did the same thing. I converted first one of them into APL, and then I just used regex to do the same thing. So I start with 4 by 4,000 bit mask, where basically all the possible numbers, they're all set to 1, because that's when they're all are in possible, and you fit it into the main one. I also have so A will just at the end add up all the possibilities, multiply all the possibilities, and R will just return nothing, 0 rather. And then it's basically the same thing, except we can't stop at matching condition because we need to try them all. So I end up creating this operator that checks the mask of the evaluates the mask of the condition. So that's the condition right here. Applies it, then reverses that mask. So that's the mask. Reverse that mask and applies it to go further to the next condition. So it just keeps calling recursively, well, not recursively, but through the whole tree. And then at the end, we just return the result. So it just accumulates for each function the result. I don't know. It was kind of funny that I was able to do that. I really like how I can kind of convert it to top to bottom. You can see what's getting you can see what's getting converted to what. but I don't know if it's a good example of APL. And then
I was curious about so that seems like that's a feasible approach, because when I looked at that and obviously heard about people converting it to defense and execute, I thought, but it looks like, you know, you have to like merge the conditions until you've got like one set of conditions that you can apply on your data, instead of having to go through each step one by one. It looked like you could take, you know, oh, if this is greater than that, then you go to that one. You take the conditions from there and merge them together.
So that's what I did. So I did the exact same thing as turn this into basically a compiler, but I compiled to a different runtime.
Oh,
Shall I share your one?
Yeah. So like part one was almost carte blanche, exactly the same as Peter's.
Right. So we're in
19. So you go up just 19. Yeah. So part one was almost exactly the same, like the same regex type of thing, the whole 9 yards. The main difference is I set up a namespace for the evaluation rather than doing it in the same space. So I create a namespace and evaluate it inside of the namespace.
That sounds like a better way to shoot yourself, a simpler or cleaner way to shoot yourself in the foot. But yes, that's nice.
Yes. So then for part two, then what I do is I set up the namespace, but I establish a set of runtime primitives for the namespace ahead of time, which modify the memory state. And the memory state is essentially a logic programming system over constraints. So essentially it sets up a set of constraint solvers. And so you have these combining and merging, which adjust the ranges. So every time you get a new greater than or less than, it shifts the constraints on where your limits and ranges are over time. So I do the compilation from the each of the rules basically up at the top get converted to these primitives, LT, GT, merge, combine, right? And then we just execute those, and each of those, when they execute, feeds itself in the state, and then we update the state as we go through, and that state is the ranges and the set of valid values. Because we got a high-low, basically. And then it spits out the result at the end.
I was about to ask, when can you combine, but
yes, you have to combine on catenations, or the comma statement, basically. So these are a set of operators that basically merge all the state together. GT and LT are both operators. As is comb and merge.
You don't use a naming convention to distinguish what's what.
What, operators and not? No. Because they're practically all operators. Like Xmas, A, and R are kind of special cases, but they're the terminals. Yeah, otherwise it's essentially the exact same thing. We're just working over a different domain.
Nothing.
And there's this fun little mutual recursion that's in there, which I think is kind of cool.
I was just about to mention that. It's rare to see that, but it's fun whenever it happens that they call it.
This is a very scheme-esque solution, I will admit. This is not very APL-y. This is really scheme-like.
Right, but it didn't look obvious from. Well, the image I had in, even I've described something similar to what you're doing. The image I had in my head was, you essentially just have a bunch of like conditional statements like logicked together, like all of our values, check if they're less than, and if they're greater than whatever, and if they're etc.
Yeah, so you could write something that analyzed all the less than the greater than and turned them into what are they? What's the SMT solver form? The standard logic expressions, and then you could have used it as a constraint solver on there. But there's no need to do that. If you know that you can execute through, you can just update your state programmatically through the thing, because there are only so many code paths.
The comments are CNF.
Yeah,
ACS.
CNF. What is it called?
Refers to.
Yeah, I think that's conjugative normal form or something like that. Conjunctive normal form. That's what I want to. Yeah, that's what I think it is. Conjunctive normal form.
Well, there's a GitHub page, isn't it?
Yeah. But that's way too much work for this problem.
Right.
Ain't nobody got time for that.
Well, speaking of time, I think it's about time we wrap this up and say goodbye. So I want to first give a couple of shout outs to, or not shout outs, but a couple of announcements. One is I haven't done my job. I'm supposed to tell viewers to like and subscribe. If you've been watching us. Yeah, Adam cringes, but apparently it works. I don't know with this amount. Thank you to all of our viewers who've tuned in throughout the time, and those of you who have either just coincidentally been here at the end or stuck it out somehow through the whole thing. That's pretty incredible.
Also, thank you to the people who are not watching it live but are watching it now in the future.
That's true. You get like yeah, and before I say thank you to everyone else, I do have to announce. So on the 27th of March is the next live online event that Dyalog's hosting, Appleseeds 24, online free live event for new and prospective users of APL, people who've just started APL, maybe they've heard about it and want to know more. Details on our website. I think there'll be links around places. Thanks to Mike, who's been manning various aspects on the technical side, chat moderating, pasting links and stuff. And finally, thank you to everyone on our panel and Isaac who left, and not Connor Herkstra who said he would be here. But he'll take that. He'll take that well. I don't really begrudge the guy. He's very busy.
Well, and thanks for sticking out for so long here, making time for it.
Yeah, no, it's a good idea. Thanks to Jay for doing the original webinar, so we could rip the format or just the title, and also for turning up, even though you don't necessarily do too much. It's
been fun. It's fun every December when I get to immerse myself in APL again as well.
Now, next, we need to start all doing the ICFP programming contest. Just get some teams together.
That has been discussed, isn't it? Yeah, right. It's another speed-based one, right?
Yeah, it's only over a weekend.
Okay. Or as in, like, do it as fast as you can, not... I guess that includes runtime. But
yeah, there's like a 24-hour lightning round and then a slower paced 3-day thing.
I think we should do the Hanukkah of data.
Oh yeah, for sure. Next year we'll do a... Oh yeah, Brian says ICFP, yes. Well, just need to make that sweet copious time and energy. Cool. And then the very last thing, I think there's a survey if you've watched this and you want to sort of give feedback. Obviously there's the comments the live chat that you'll be seeing on live replay if you're watching this in the future, or there's just regular YouTube comments down below. And then there's also a survey linked in the description and in a QR code on the screen, which I'll show when we end this. So if you've watched and you've enjoyed, or you've hated it, or you just want to spout some opinions, then please check that out. Other than that, yeah, thank you everybody, and see you next time.
Bye.